materials. I've got it on my desktop here, and in fact I'm actually going to copy it into my project folder. There it is, copy, there we go. And so now I'm going to get Excel and open up the cap curve template, and I'll walk you through it. So I've already zoomed in. Normally it's like this, this size. So this is zoomed in, and over here you can see a confusion matrix which will be populated as soon as you copy in the data, which is always nice to have, like a nice bonus for you over there. But mainly the cap curve is over here. This is the main working area for the cap curve. And going from the top, you can see right away total number of exited. That's the total number of successes that you're going to have in this column and column B. So from here downwards. Then total successes, I mean, of course, like ones in your binary outcome for the dependent variable. Then total records, that's the total number of rows you're going to have in your data. Percent exited is the rate at which the exits, so one divided by the other. Row number is basically just required so that you have a row number in here. Then exited is your binary outcome, so your actual, what was actually observed. And p hat is what your model predicted, so the probability that the model predicts for that specific row number to exit, and that's why the row number is in there. And then you've got the gray, blue, and pink, as we discussed previously. So what you need to do, and we'll do this in a second, what you will need to do is you need to copy your data here, and it has to be ordered. So you see this instruction here, and that means that you have to order your data by p hat first in descending order. So the most probable people to exit should be at the top, which makes sense, right? So if you're going to contact them, you're going to contact the most likely ones to perform the action first. And then after you've copied your data in order, in its ordered form, then you will need to populate this bit. So you'll have to delete this row and then just drag this cell downwards. Just this one row, these 6 cells, you just drag them downwards to match the number of rows you have here. So let's go ahead and do all of that. Where's our project folder? And now we are going to look for churn modeling forecast. So that data set that we prepared previously, I'm going to bring up another Excel, and I'm going to drag churn modeling forecast. By the way, here's a quick tip for you. If you want to bring up another Excel like I did here, quite a few people have asked me this actually. Very easy. On your start menu, which I don't have brought up because it's on my other screen, all you have to do is, you know how you click Excel there? You left click to bring up a program in the toolbar. It's the taskbar, in the taskbar. Well, just instead of left clicking it, click it with your middle mouse button. So click it with your wheel, and like I can bring another one, and there's another one. I'm just clicking it with the middle mouse button. And so if you, instead of going through file, open a new Excel and so on like this, you can just bring up as many of them as you want. And, you know, maybe that'll help you out. Maybe that'll be a handy trick you'll use someday. Otherwise, you know, all of your tabs, all of your worksheets are in one Excel, and you can't freely move them around like this. I find this is sometimes handy. Anyway, back to our research or analysis. I'm going to zoom in here, and I'm going to select all of this. And I'll do it, I'll put in a filter like this time. So we'll order largest to smallest. There we go. So remember, you don't need to copy the top row. You just need to copy, you don't need to copy the header. You just copy all the data. There we go. Copy. And let's paste it in here. Voila, there it is. Data is in there. Now, one thing you should keep in mind, I'm going to expand this. By the way, here's our... here is our confusion matrix. It's working totally fine, so that's good, that's exciting. You can see that the total in here is 10,000 a record, so we see here 10,000. You can always just do that check. And the other thing I wanted to mention was, look in these formulas. You can see that I've put them up to 1 million, so this formula goes from here all the way down to 1 million. This formula goes from there all the way down to 1 million. So just make sure if you have more than 1 million records in your data set, well, first of all, probably Excel won't fit them, but Anyway, just make sure that you're not exceeding this limit. If you are, you might have to adjust this formula. Otherwise, everything looks good. We've copied our data, and now we're going to do this part. So I'm going to just delete this text, and you can just go ahead and drag them like that, or the fastest way is just double click this little square, and they get dragged all the way down to, like, I'm just going to press Ctrl down, and here you can see that exactly how much we need. Okay, everything looks good. All you have to do now is the last bit. Just select through Ctrl, hold down Ctrl, select E, G, and I. Insert line, this line, bam, get rid of the legend. All done. That's how you use the cap curve template. As you can see, it's the same result as we had previously. If you want to insert a shape, just go ahead, hold down Shift, and that'll be a vertical line. And there you go, so that's 80.5%. That's how you use the cap curve template. It's all yours to take away and use in your own work. That's it. Have fun, enjoy, and I will see you in the next tutorial. Until next time, happy analyzing.
In this tutorial, we're talking about the difference between training and testing your model and how to avoid overfitting. Here we've got the data set that we want to build a model for. And what we've learned so far is that we have to simply select the right parameters and throw them into a logistic regression, and that will spit out scores or probabilities that we will be able to use in our geodemographic segmentation. And that is all good. However, you might want to take a part of your dataset, a sample, so a random sample, about 10 to 20%, and split them, separate them from the people that, or the records that you're actually going to be inputting into your model. And why is that? Well, the reason for that is that then you can move these people aside, or these records. You can train your model just on the remaining 80 or 90% of your population, or of the sample that you're training your model on. And then later you can test how your model works on the sample that you've separated. And that way you will be sure that that test, the second test, is not biased. So as a result of testing this model, or training it and then testing it, you'll have two accuracy ratios. So one accuracy ratio will be for the trained data, and that is the larger data set that we'll be building our model for. And then you will have an accuracy ratio for your test data set, the smaller one. So the first ratio, the train ratio, even though it does tell us a lot about the model, at the same time it might be a bit biased because we did use the same data set to build the model, and now we're checking how the model predicts that same data set. Whereas the test dataset is completely separate from the model. Those records were not used in the construction of the model, and therefore the second accuracy ratio that you will get will be a validation for the first. So if you see a significant difference, then that means that perhaps your model might be overfitted for the data that was used to generate this model. Remember, we talked about overfitting, that if your model relies on some anomalies or some specifics of that data set that you put into the model, then it might become overfitted, and then when you apply it to real data, the results might be different. Well, here you're kind of creating a safety net for yourself, that if it was overfitted, or if the model isn't the best performing model, so it's just working good on the training data set, then you won't find this out on real data when you actually make predictions. You'll find it out early on. You will see it on the test data set, and that way you'll be able to rebuild the model. So if something goes wrong, you just go back and you use the old training data set to build a different model, then you do the same procedure. So separating a test dataset is very common. It is actually a standard technique used in modeling, and you should definitely do that when you are creating your own models. In our example, when we're building our geodemographic segmentation, the test dataset has already been provided for us, and as you will see in this section, we'll be using that to verify the model that we've already created. However, further down in this course, I will show you some tips and tricks on how to properly separate a test dataset, because even such a trivial procedure has some underwater stones that come with it. So we'll definitely talk about separating your training and testing datasets further down in the course. Now that we've talked about training and testing your model, today we'll actually start doing this in practice. Today we will run our model on the test data set that we have been supplied with, and in the next tutorial we'll actually compare the performance of the model on the trained data and the test data. So let's go ahead and do all this work now. So GeoDemographic segmentation, and here are the two data sets that we started with, churn modeling and churn modeling test data. In order to run this model on the test data, I'm going to do the following thing. So I'm going to bring up Excel. I'm going to copy the test or the normal churn modeling data set in here, and then I'm going to copy the test data set into a separate Excel file. So now I've got two of them here, and all I'm going to do is I'm going to take all of the rows from the test data set except all of the columns except for the last column, which actually tells us the result, because we don't want the model to know the result for these people. And I'm just going to copy all of them. So I'll go to the bottom. There's 1,000 records here. I'm going to copy them, and I'm going to add them to this data set at the bottom. So I'm just going to copy them in here. So here you can see that they've been added at the bottom, but they don't have the result, right? So now when we put the model into, or the data into Gradle, and we build the model, we're going to be using these records because they do have the result, and Gradle can build the model based on the outcome, so it can find the right coefficients for the model. And then we will use these to actually evaluate our model. So we will ask Gradle to come up with probabilities for these records, and then we'll assess the model on these records separately. So I'm going to save this as a separate file so I don't overwrite my existing file. Churn modeling. Let's call it with test data appended. Okay, we'll save that. So there's our data set, and now we're going to run Gradle. File, open data, desktop, and there it is. And that's all good. So basically we're just doing the same thing as usual right now. What do we normally do? We add dummies for gender, and we add dummies for geography. So I'm going to change this France. Okay, so I've created the dummy variables, I've renamed them, and I've added the log balance variable. Now what we need to do is we need to rerun the model. Here we've got our parameters, and I'm going to put them into our model. Alright, so I have inputted all of the regressors into the model. I've put in the dependent variable, show p-values, put the tick here. Looks good, so now we can run the model. And what you should see is you should see exactly the same coefficients as we had previously. Same R-squared, everything. Because even though we did add records, Gradle's not using them. Gradle's only building the models using observations 1 to 10,000. Because the last 1,000 records don't actually have a value for the outcome, and therefore Gradle cannot simply just cannot use them in the modeling process. But what we can do now is we can go to analysis forecasts, and we want to forecast for this range. You see Gradle Smart is already picking up the range from 10,001 to 11,000 for those records. We don't want any pre-forecast observations, so we'll put a 0 here, and we don't want fitted values. It doesn't really matter because we're not going to have any of those anyway. So now we'll just click OK, and there you go. So these are our new records that we added from the test data. As you can see, they don't have an exited value, but they have a prediction. And this is the fun bit. This is the important bit, that Gradle, without even knowing, without knowing what is going to happen to these records, it built a model on the other records, as we discussed in the previous tutorial, and now it has applied the model to the new records. And as you can see, there are probabilities here. Now, what is the interesting bit is how right has Gretel gotten them, yeah, or how right has this model gotten them? How correct is our geodemographic segmentation? Because we actually know the result, we just didn't include it in the file. It's in a separate file. And that's exactly what we're going to do now. So we're going to save these records. This is not going to be exit hat. This is going to be p hat, as we discussed. P hat, and maybe we can call it test data. And here we're going to say for probability. Okay. So we've saved that. Don't need that. So there's our new data set, new column, and now we're going to export it. File. We're going to export data. So all we need is row number. We don't need customer ID. We only need row number and p hat test data. CSV, comma, okay, I'm going to save it here. And at the end, I'm going to add, as last time, forecast. Save. Don't need that anymore. All right, so there is our data set. Let's open up Excel and have a look. There it is. So NA means that these records didn't have a prediction because we didn't ask for them to be predicted, and that's right, that's the first 10,000 records. And then as you can see, the predictions begin here. So what we're going to do is we're going to remove these records that don't have predictions. All right, so this is our test data predictions. Now what we're going to do is we're going to open up our previous test data file, so the original one. And now what we want to do is, let's get rid of this one. We want to copy the actual exited value from here into here. So normally what you would do is a VLOOKUP, right? But I'm not going to waste your time with that because I know that I can already see that they are lined up correctly. So I can just take this column, exit it, and copy it into here. And I can close this. And now what you'll see is that we don't just only have the probability, but we also have the exited value. So this value didn't participate in the modeling, but we have appended it now, and we can verify how well our model went. The last thing we want to do is copy it and just put it before this column. So should have done that. Anyway, so now we can see that row number exited and then p hat test data, because that's the order in which we need to copy them into our template. And that is we're going to use our cap curve template in the next tutorial to build the cap curve and then compare the results on the train and test data. So don't forget to save the file, and once you're done, I will see you in the next tutorial. In the previous tutorial, we ran our model on our test data, and here's the result. So we have the row number, we have the predicted probability of the person leaving, and we have the exited, the actual value. Did the person leave or not? And I just want to clarify one more time that when we ran the model, we did not use this test data. We created the model using the main data, which is in our churn modeling file. Then we input this data, or it was appended to our churn modeling file, but these test records, they didn't have the exited column appended. We added that later. So this prediction is in no way associated with this exited actual value. And so what that means is the model is predicting whether they will or not they will exit, and all we need to do now is actually check how well it is predicting, because this is like the real deal. It's a simulation of a real application of the model in a real environment. So what we want to do now is run this data through our cap curve template. Now let's go ahead and do that. So I'm going to bring up the cap curve template. There it is. Maybe expand this whole thing. Okay. So where is our data set? It's in this file. And the first thing we need to do, remember, we need to order our data set by this last column. So by the way, I'm going to maybe this time just do it like this. So data, filter, and now I will sort it by largest to smallest. So that's the most probable person to leave, and the least probable person to leave is at the bottom. That's the probability. And now all we have to do is copy this data, copy, and go to our cap curve template. Alright, and we need to put in here, remember it says ordered, so we did do that, we ordered it. So I'm going to paste it in here. Okay, I'll just, that's right, I click delete. There we go, let's do it again, paste. So that's good. You can see there's a total of 1,000 records, total exit is 260, 26% exited. Now we will delete this, and all we need to do is take this last row, not two, just the last one, and either drag it like that, or you can just double click on the corner and it will automatically go to the end. So as you can see, it's all populated. Just go down to the bottom and check that there's no issues along the way. Yep, so everything adds up at the end. There's 1,000 records, 260 exited, 260 exited, 100% everywhere. Everything's good. Okay, and actually even the confusion matrix is already populated for us as well. So you can see how many type 1, type 2 errors the model has made. And now all we have to do is, as we did previously, select this column, press Ctrl, hold Ctrl, and select these 3 columns, insert, line, bam, done. So get rid of that. There is our cap curve. So that's what it looks like, and it looks very similar to the one we had for the real for when we were building the model, but it's a bit different. So if I do the 50% line, which is somewhere over here, you can see that the model is performing less than 80% at the 50% line. So once again, we're not going to calculate the area and then the area of the ideal line and calculate the actual accuracy ratio. We'll leave that to stats programs to do. But just by looking at this picture, we can see that the model is performing well, really well, but a bit worse than it was on the trained data. So let's go ahead and bring up the trained data result over here so we can compare side by side. There it is. We saved it in our Excel file over here. So this is what we had before. This is what we have now. Alright, so here they are side by side. And you can see 2 things right away. First of all, the model is performing a bit worse on the test data. And you can see that because at the 50% mark, the model is only capturing about 78, I would say, maybe 75% of the churners in this scenario, in the test scenario. At the same time, in the training environment, the model was able to capture 81%. So about a 3% drop over there, 3 to 6% drop, just moving from trained data to test data. And don't forget that the test data is pretty much just part of the test data is part of the trained data, just we separated it before we built the model. So these people actually came from the same time snapshot that when we created this whole data set. And the second thing that you can see is that this model is a bit more rugged. So like you can actually see the bumps in this model. They're more obvious than they are here. This one looks a bit smoother. So the second observation, it can be explained by the fact that there's less records. So there's only 1,000 records here, and therefore the concentration of records here is 10 times less than here, and therefore any kind of deviation or anomalies or randomness in the records, you can sense it more because there's just generally less records, and therefore that's why the line looks less smooth. Here you can still see some ruggedness, but it kind of smoothens out because there's 10 times more records, and even if 1 or 2 are deviating from the norm, then they're smoothed out by the other 8, and as opposed to here where there's 10 times less. So that's the first thing, and you will notice that the less data you input into the model, the more of these jagged lines you will have. And the first observation, the main one, that the deterioration of performance, well, there's a couple of reasons why that could be. First of all, perhaps maybe our model is overfitted, and you will find that to a certain extent models will it's natural for a model to be better fitted to the data that it's trained on. It's like in anything. Say even if you're doing martial arts, right? You're better at the gym that you are training at than at a gym where you go to. Or let's say soccer or American football, right? If you're the home team, you will always play a little bit better on your own ground than when you're playing away on somebody else's field. So that's okay, as long as it's not too much of a drop. The other reason why this could happen, the drop over here, is once again because there's less records. Because we only have 1,000 records for this test, which is okay, which is fine. But maybe there is some, maybe all of those records, somehow it happened that they are a bit skewed one way, or they have a certain characteristic that these other records don't have, and that can affect this what you're seeing. And that has also to do a lot with how the sample or the test sample is selected from the overall the whole data set that you have for your training and testing. It is very important to select it correctly, and we will talk about this further down in the course, how to correctly select your test samples to minimize any potential for this effect when just because you select your test sample incorrectly, the results are not matching up. So, but otherwise, this is good. It validates that our model is performing. So basically, in this case, even without knowing anything about this data, our model was able to predict quite well. So imagine this, like you can, by contacting just 50% of your sample of these 1,000 people, by contacting 500 of them, you will get nearly 80% of those who are actually at risk at leaving, at a high risk, that will actually leave. So that is a great result, and that's why we consider models between 70 to 80% good models. And yeah, so our model has passed the validation. This is how you use test data to validate. One other thing I wanted to mention is that this is a very powerful technique that we use just here. We plotted the cap curve, the cumulative accuracy profile for both models, and we compared it. So just visually comparing. Of course, we can calculate the area and so on, be more mathematical about it, but just visually comparing, we can tell right away which scenario is better. So the model is performing better here. But you can also use the same exact technique to comparing models to each other, different models. So if you had two options of a model, so you created one model and then you created the second model, and you didn't know which one was better, then you could put them side by side like this, use this same template, the cap curve template, create the cap curves, and for two separate models, but run them on the same data set. So here we're using different data, we're using trained data and test data, but if you run them both on the test data set, for instance, this model on the test data set and then a different model on the test data set, and you can just say in the same way compare visually the graphs, and that way you can assess which model is better. And it's not just going to be like a random metric or an unreliable metric like the accuracy rate from the confusion matrix. Here you can actually, it's a more reliable metric because, as you can see, it's taking into account all the records. You can visually see how it's going. So if there's any problems with the model, you will find that you will see it right away. And the third scenario when you can use this technique as well is when you're comparing a model to itself over time. So this is how your model is performing now. This is how it's performing on test data. And then 6 months later or 12 months later, you run this same test, but for a new data set in the future, like for the people that are going to be banking with you in 6 months and for their behavior and for that geopolitical environment, you run the same model on those people and you see how it changed. You look at the curve, and this is a very important technique. We'll talk about this more as well when we're talking about deterioration over time. I just wanted to run ahead a bit so that you're prepared and you're kind of thinking about this already now before we get to that tutorial. You will see that over time, maybe your model will be getting worse, and like this curve, this red curve will be getting to the blue one every time you check your model every 6 months. And that will speak of model deterioration. But more on that later. This is all for today. I hope you found today's information useful, and definitely use this technique in your career. It can help you create much better models. Already, end of the section, we were just getting started into the fun stuff. But don't worry, in the next section, we will talk about some very powerful insights you can derive from models. And for this section, this is what we learned. Number one, we talked about the accuracy paradox, and that helped us understand why we cannot just use the accuracy rate, which comes from the confusion matrix, as the driving factor for defining whether our models are good or not. Next, we talked about the cumulative accuracy profile, and we got so used to it that now we just call it the CAP or the CAP curve. And basically what it is a measure for how well your model is performing. There's a mathematical way to assess the CAP curve, which is calculate the area under the ideal scenario, calculate the area under your model scenario, and then divide one by the other, get the accuracy ratio. However, we also talked about a rule of thumb, which is very visual, which is very quick. Just look at the 50% line, see where your model is sitting there, and then you have some certain thresholds, which I told you about, the ones that I personally use. And then what we talked about is how to build a CAP curve in Excel, plus you got the template. So hopefully you now know how to build one, but also hopefully the template will save you lots of time and you can just use it again and again and again. Took me a while to come up with that template. Usually for me it was always very messy when I was building these CAP curves, but now I know how to structure it in a great way so that it's very efficient and I don't get cluttered with all of these extra columns that I don't need. Number 4 is how to assess your model using the CAP curve. So that's we talked about that already. That's the 50% line, and just visually see how it is, how the curve is structured, how close it is to that ideal curve that you can never achieve, but you always want to get as close to it as possible. We also talked about overfitting models and how you can avoid it. So using a train data and test data, so separating a test group from your data set early on, so that further down the track when your model is ready, you can actually apply the model to your test data and then see how well you went on in that scenario. So then compare the accuracy ratio in your train scenario and your test scenario and make sure that there was no overfitting in your train data. We also practiced how to verify models via test data. So we didn't just talk about the theory, we actually did it in practice. And this time we had our test data prepared for us or separated for us in a separate file. Further down the course, we will talk about the correct way of separating your test data from your training data yourselves. But this time we already had it, and we did actually practice and visually compare the two. And I really think that's a good exercise, because you'll be doing quite a lot of that if you want to build robust models. And number 7, there was a preview as to what's coming next. So we talked a bit about how models can deteriorate over time and how you can compare models side by side, even if they're different models, using the CAP curve. So all of that's coming further down the track in this course. Hope you're enjoying the material so far, and I look forward to seeing you in the next section of the course.
Welcome to this section on deriving insights. Now that we've built the model and we've assessed its performance and we're comfortable and confident with it, we can finally derive some insights. I will show you how to use the cumulative accuracy profile in order to understand how your business can become more efficient and save costs at the same time. We will also talk about the coefficients of the logistic regression to understand how your business can take advantage of certain patterns in the behaviors of your customers. So this is going to be a very interesting and insightful section, and I look forward to seeing you in the first tutorial.
Today we'll talk about drawing insights from your CAP curve. The CAP curve is actually a very, very, very powerful feature in modeling, and you can derive lots of valuable insights for your business just from this one tool. So let's see what we can get from here. We're going to look at 3 things. The first one is the obvious benefit of the likelihood score. So the score that we get by running our model tells us which customers are most likely to leave the company. In this case, it's leave the company. It could be take up an offer, or for which observations the event is most likely to occur. So where is it most likely? that the dependent variable will be a yes, a 1, and not a 0. So this score allows us to already derive insights, and we can rank our customers, we can create deciles or quartiles and address different groups of customers differently. So if they have a high score, then they'll have one treatment. If they have a low score, they'll have a different treatment. Maybe it will be a different offer. Maybe it'll be a different type of message and things like that. So that's the first thing. And that's kind of before the CAP score. That's already an obvious benefit for the business, just having this ranking available. So a new parameter of your customers gives you a lot of insights which you can work with. Now the CAP curve itself gives you two main things. The first one is to do with budget constraints. Let's forget about this situation for a second, that we're dealing with customers that are churning, and let's imagine that the model that we've constructed is for customers that take up an offer. So basically we send an email offer and we built a model to see what is the likelihood of customers actually clicking on our link and buying the product. So the end result that we're measuring, the dependent variable, is did the customer buy the product or not. And in that case, here we've got total number of customers that we in our test was 10,000. Total number that bought the product was 2,000. The percent that bought was 20%. And here we also have the same score, but this time it means that the likelihood of the customer to buy. So the predicted probability that the customer, this specific customer in this row number, will actually go ahead and purchase the product. And what does the CAP curve tell us in that case? Well, it allows us to, once again, we're using the ranking to create the CAP curve. So at the start, we'll have the most likely customers to buy. At the end, we'll have the least likely customers to buy. Now, when we're talking about budget constraints, this is a very, very common feature. And this is something that you might come across in a marketing department in a company. And let's say they can only send this email to a certain number of customers. Of course, an email isn't that expensive to send. It costs maybe like, I don't know. I don't have the exact figures, but I would assume maybe about 1 cent or 1/10 of a cent to send an email or something like that. But it still costs some money. So if a company has 10 million customers, and even if it costs 1/10 of a cent to send an email, right? So that's already going to, what's that going to make? Like $10,000 just to send all of those emails. And obviously the marketing department has other activities to do, so they might allocate a certain amount of money just for this specific activity and might not be sufficient to cover all of the customers of the company. And in that case, you have to pick and choose who you send to. If you don't have a model, then you will have to send to a random sample of, let's say you have 10 million customers and you can only send it to 5 million. In that case, you would have to select a random sample of 5 million and just send it to them. But if you have a model, then it's very obvious who you're going to send it to. You're going to send it to these first 50% that are ranked here in the top 50% because they have the highest likelihood of responding. And in fact, you can tell right away from the CAP curve, you can go back to the marketing manager and say, look, I have a model, I've built a model for you, and you can, even if you send to 50% of the overall base of our customers, you send this offer, you will already hit 80% of the churners. So yes, ideally, or 80% of the people who are most likely to take up the offer. Let's fix up this axis over here so it's not confusing us. So maximum will be 1, right? Let's close that. So that makes it a bit better to visualize, right? So what you're saying is it would be ideal if the marketing manager could send it to everybody, and then he would obviously hit 100% of the people that are likely to actually take up the offer. But you understand that you and the marketing manager, that you both understand that this is budget constrained, and he can only send it to 50% of the customers. If he sends it randomly, right? If he sends it to a random 50% of the customers of the company, he'll obviously looking at this blue line, he'll obviously only get 50% of the people that churn, which makes sense, right? If you take 50% of a sample, you'll get 50% of, I keep saying churn, you'll get 50% of the people that are actually going to take up the offer. But if he uses your model, then if he sends it to 50% of the people in the company, according to your model, according to your ranking, then he will actually benefit because he knows that he'll contact about 80% of the people who will take up the offer. So he's getting more for the value, more for the money that he's investing. He's expecting to only get 50% of the people that will take up the offer. He'll actually get 80%. And that is how these models and the cap curve can help you in situations with a budget constraint. So even if you can only contact 25, right, over here, you might see that the effect is even stronger. So here you're going from 50, instead of 50, you're going to 80%. Yeah, so that's a 30% increase, so a relative increase of just more than half, right? Over here, this part is just more than half of this part. Well, whereas if you only have 25, right? If you can only contact 25% of the people, then you're going from 25% of the people that'll take up the offer, you're going all the way to 55% of people that'll take up the offer. You're more than doubling his expectation over here. So, and that's like a normal thing to observe. Whenever you're to the left of the halfway line, you're more likely to increase the benefit substantially. When you go to the right, the benefit is increased less because the curve is much steeper over here. So you can already tell that whatever budget constraint you have, you can add a lot of value to the business. So like even here, instead of if he contacts 8.3% of the customers, you can help him reach 22% of the people that are likely to take up the offer. What a value add to the business. Marketing manager will love you for this. This is incredible stuff. So that's the first main benefit of the cap curve. And the second benefit of the cap curve is efficiency. So sometimes you might not have a budget constraint like this, but at the same time, what's the point of sending the email to 100 people when you can send it to 100% when you can send it to less and still get approximately the same result? So let's go back to our example of churners, right? Here, for instance, let's say you can contact all of your customers in your company and then you'll definitely hit the 100% mark. But at the same time, you already know that these people on the back of this curve, they're very unlikely to leave the company. The likelihood of churning is very low compared to these people, right? So that's number one. Number two is, even if you contact, so this is somewhere about 80%. No, that's not 80%. That's 80%. So this is even less. This is about 70%. So even if you contact about 70% of your customers in your bank, you will already cover approximately 91% of the people that are likely to leave your company, that are likely to leave your bank. So that is very close to 100%. That's number one. And number two is that the remaining 9%, they're actually very, very unlikely to leave your bank. The likelihood is minimal. So therefore, you're saving these 30%, the money that you would spend on contacting these people. And not only the money, it's also messaging people without, you can't send too many emails to the same person in a month or even in a quarter because they'll consider it as spam and it's not a good customer experience. So you're saving the money and you're saving the people the trouble of having to read this email, which isn't that relevant to them. And you're still getting a lot of the potential churners. You're getting 90% of the people that are actually going to churn. So you're getting 90% of the people that will churn. Even if you contact just 70% of the customers, you're getting 91%. So I think that's a good trade-off. You save money, you save people the trouble of reading your email, and you get the most likely ones that are going to churn the company just by contacting about 70% of your customers. So this talks about efficiency, how you can add efficiency to existing business processes through looking at the cap curve and creating models like this. And those are the two main benefits that you can derive, so budget constraints and efficiency. Let's recap quickly on what we learned in this tutorial, because I feel this is quite important stuff. Insights from your cap. The first one was actually before the cap curve. This is the likelihood score, and this is the score that you get for your customers. It adds another dimension to your understanding of your customers and allows you to work with it and create offers based off of it, or segment your customers according to that new dimension. It's a very insightful feature that can be used across the business for different for lots of various things that you might be required to do with your customers. Number two is budget constraints. So you can use a cap curve directly to understand who to contact to get the best bang for your buck. If you have a budget constraint in your marketing department or whatever department you're creating this model for, this can really, really help get the best outcome for the investment into this activity. And three, efficiency. Sometimes you won't even have budget constraints, but creating a model and building a cap curve will help you increase efficiency in terms of understanding where to stop, when to draw the line of who you want to contact, who you don't want to contact. And this doesn't only have to do with contacting people and in customer related companies. This can be in any type of organization where you're creating this model. It will help you understand where to draw that line. And actually, last thing I wanted to mention before we go, sometimes your cap curve won't have a flat profile like this. Sometimes there might be kinks in here. Even in our cap curve, we see a little bit of a kink over here, a little bit of a kink over here, then a bit of a kink, a few kinks over here, but they're not that pronounced. If you have more pronounced kinks, which of course you have to make sure that they're not crazy. If your cap curve is like going all over the place, then something's wrong with your model. But if your kinks are a bit more pronounced than they are here, then that can give you some hints where to set the cutoff points. So let's say, for instance, you want to set a cutoff point in terms of efficiency somewhere between 20%, so between this line over here, and let's say 40%, so between this line over here. And you don't know where to set it. You can pretty much set it anywhere. You can set it at the maximum, at the minimum. But then you see a kink over here, and you see that the cap curve is growing really fast before the kink, and then let's say during the kink it flattens out, and then it grows slowly. Well, that's giving you a hint that any investment, additional investment that you make after the kink into this specific project or into this specific activity is going to yield a much lower return on investment than what you had before the kink. And that might be a good place for you to set the cutoff point. So you set it right before the kink if the curve flattens out afterwards, and that way whatever you're losing between the place where you set off the cutoff point and your maximum threshold for the cutoff point is not going to be as great. So basically you're finding a great place to set your cutoff point just by looking at the profile of your cap curve. Once again, that's not all the time. Sometimes the model will give you hints and ideas like that. And going back to our presentation, 1, 2, and 3, likelihood score, budget constraints, and efficiency. Those are the 3 things that you can derive from your model. The last 2 are directly from your cap curve. And I hope that these techniques will help you to help other people in your company and also work around budget constraints and add efficiency to existing business processes. And I look forward to seeing you next time. Until then, happy analyzing. Plan of attack. All right, Kirill, what is this all about? What are we talking here? What kind of attack is going on? What we're going to be talking about in the next couple of tutorials is an advanced topic, and that's why the tutorials are marked as advanced. And we will be looking at a very specific thing. Let me explain. Remember, we previously talked about the do's and don'ts of a logistic regression. And we specifically said that you cannot interpret magnitudes of the coefficients to quantify associations between the dependent variables and independent variables directly. And this is very different to a multiple linear regression. So this is our logistic regression here, and we can't look at the magnitudes of these coefficients to compare the different variables between each other. We could totally do that in a multiple linear regression. It was very handy to tell us which independent variables are having a more significant impact on the dependent variable and which are having less. So basically comparing independent variables between each other and also actually physically quantifying the effect of the change in the independent variable and how that will affect the dependent variable. But here for logistic regression we can't do that, and that just hurts. That hurts so much. We have to be able to do it, and that is why we have this special part of the course, this special couple of lectures or tutorials which are advanced, because they will involve quite a bit of mathematics and some advanced understanding of probabilities and odds ratios and things like that. But if you can power through them with me, I have broken them down into manageable sections or manageable topics, which we will cover off in the next tutorials. And today is about setting that plan of attack, and it's pretty straightforward. So first, we'll talk about the odds ratio. It's an important topic. You will see what odds are in sports betting, so that's kind of like a side effect of this section of the course. You will learn a bit more about odds in sports. But the main focus of this tutorial will be to link odds and probabilities. Then we'll talk about coefficients. So this will be the math heavy tutorial where we will actually understand how to plug odds into our logistic regression and then see for ourselves how a 1 unit change in a independent variable translates through the coefficient into a change in the odds. So there's your hint, wink wink, into a change in the odds, not in the probability. So that's going to be interesting. And then finally in the third tutorial, after this plan of attack, we will see the practical application. I will show you how to get the odds ratios in Gradle. I will show you how to export everything into Excel, how to prepare your report in Excel, and then actually how to put it into PowerPoint, and the way I would go about presenting your logistic regression or your geodemographic segmentation to your manager. So we'll have a heat map, and it'll be very, very evident what the main insights are from our geomographic segmentation and what the bank, in this case, what the bank should do in order to address the issue of increased churn. So it's going to be an exciting couple of tutorials. Bear in mind they are going to be advanced, so prepare yourself for some advanced mathematics. Well, I wouldn't say too advanced, but some mathematics are going to be in there, but we'll definitely power through them together. And I look forward to seeing you next time. Until then, happy analyzing. Odds ratio. We hear about odds quite a lot when it comes to sports, whether it's betting on horses or on soccer matches or even gambling. And I bet you've heard phrases like the odds are 10 to 1 or the odds are 7 to 5 or the odds are 3 to 2 in favor of this and that and etc, etc, etc. And today we will talk about odds. We will try to understand what exactly odds is. But more importantly, we need to understand how is probability linked to odds, because we will be working with these terms quite a lot in the coming tutorials in this section. Here are the odds for the Melbourne Cup. The Melbourne Cup is a horse race which runs in Australia in November every year. And what we're looking at here are the dollar odds. And I'd just like to say here right away that I'm not advocating gambling or anything. This is just a great example for us to do our calculations of, and nothing more than that. Here we've got dollar odds, and as you can see, they're increasing for these 10 horses as you go down the list. So what do they mean? Well, basically it's telling you how much money you will get if that specific horse wins. So as you can see, the horse at the top will bring you the least money because it is deemed to be the most favorable horse, the most likely to win the race. The horse at the bottom will give you the most money because it is deemed to be the least favorable horse out of these 10. Now we want to move on to a different type of odds. We want to talk about losing to winning odds rather than dollar odds. So how do we convert dollar odds into losing to winning odds? Well, first of all, you have to split the dollar odds into two parts. Here what the dollar odds are telling you is that if you put $1 on this horse, which is called Fame Game, the first one in the list, then if that horse comes first, you will get back $11. However, those $11 already include your $1. So basically, you're going to win only $10. So let's just quickly recap on that. If the horse doesn't come first, you won't get your $1 back. You will lose your $1. Or a random person who's betting on this horse will lose their $1. Now, if the horse does come first, you will win $10 and you'll get your $1 back plus $10. So in total, 11. So therefore, if you divide one by the other, in the case if this is a losing horse, then there's a $1 loss. If it's a winning horse, it's a $10 win. So $1 to $10 is your losing amount divided by your winning amount. However, the losing to winning odds are different. They're inverse. So basically, you have to take the two amounts and flip them. So the losing to winning odds are 10 to 1. Now, why is that? It might be a bit confusing, but why is that? Well, because you're getting, if you win, you're getting $10. So obviously that must be a much less likely event than the event of losing, right? Otherwise, that company that is running these odds is going to go bankrupt. So what this means is that you will get $10 if the horse wins. However, it is expected or assumed that this horse will only win 1 out of 11 times. So if there's 11 races, then 1 time out of these 11 races, the horse might win. Well, will win. That's what this company that did this calculation is assuming. And on the other hand, you're losing $1. You're losing a tiny amount. But why is that? Well, because the horse will probably lose 10 out of 11 races. And that's how the losing to winning odds work. So in this case, an $11 odds actually means a losing to winning odds 10 to 1. So you might hear the phrase that Fame Game has 10 to 1 odds, meaning that it will only win 1 out of 11 times. And therefore the amounts, the remuneration is calculated through that as well. So now we want to get to probabilities. How do we calculate the probability of winning? Well, it's pretty simple. You just need to add the two numbers. 10 plus 1 is 11. As we said, like out of 11 races, the horse will probably win 1 time. So you take 1 divided by 11, gives you 0.09. So there's a 9% chance of this horse winning. Now be careful in terms of terminology. At the top you've got losing to winning odds. And at the bottom you've got the probability of winning. If you want the probability of losing, then it's obviously 1 minus the probability of winning, which gives you 91%. Now let's concrete all of this in by putting it into a formula. So some math. What did we do just there? If we assume that losing to winning odds is given by this ratio L to W, then what we did just there was probability of winning equals W divided by W plus L. So if we take 1 minus probability of winning, it will give us L divided by W plus L. Now if we divide one by the other, we'll get probability of winning divided by 1 minus probability of winning equals W divided by L. And if we rewrite that, then our winning to losing odds, so not the losing to winning odds, but the winning to losing odds, W divided by L equals probability of winning divided by 1 minus probability of winning. Now if we put that all into a formula, this is the formula we get. Win to lose odds equals P divided by 1 minus P. Now this is all we need from this tutorial. From here you can move on to the next one. We are going to be working with odds. However, if you want to stick around, I wanted to show you something extra, a graph of this chart. Why I wanted to show it to you is just so that you kind of can grasp what's going on here and have like a kind of visual understanding of odds in your head. So feel free to stick around. I'm going to bring up the chart now. So here's a website. It's a German website, one of the first ones I found on Google to plot a chart online. And what we're going to do is we're actually going to just input this formula into here and see what it plots for us. This is x squared as default. That's not what we're after. So let's go ahead and plot that. So I'm going to take x. In this case, x is going to be instead of p, right? So x divided by 1 minus x. I'm going to plot in blue and let's draw that. So what you see here is the function, which looks like that. But we also know that probability in this case, x, is always between 0 and 1. So it can only be between here. So let's cut it off at 0 and 1. And let's draw that. So here is your function, right? Let's maybe change the x-axis range. So we'll start x-axis from 0 and the y-axis from 0 as well. So let's draw that again. And so that is how your function looks. As your probability is changing, maybe we can also change this bit also. So x-axis goes to 1. Let's try that. So there you go. So here you can see that as x, or probability, changes from 0 to 1, like from here to here, what happens to your odds is it changes from 0 to infinity. It goes all the way to infinity. And why is this helpful? Well, this shows you that as probability increases, your odds, the good odds, the odds of winning. So remember, there's two types of odds: losing to winning odds and winning to losing odds. The ones we're talking about here are winning to losing odds. Those are the ones we're going to be talking throughout the rest of the tutorials in this section. The winning to losing odds are increasing, and that's important because we'll be relying on this information further down, that as probability grows, the winning to losing odds, or the odds ratio, is growing as well. If probability is decreasing, the ratio is decreasing as well. You can already tell that from the formula right away, but at the same time, having this chart visually present in your mind will allow you kind of to remember this and always be, confident in what you're doing and what we're talking about with the odds ratio. So that's how the odds ratio works, and we will definitely talk about it more in the next tutorial. We'll take it where we take it to the next level, and I look forward to seeing you then. Until next time, happy analyzing. In the previous tutorial, we talked about odds and how they link to probability, and today we're finally going to get to the bottom of this challenge with the coefficients of a logistic regression. I gotta warn you right now, it's gonna be a math-heavy tutorial, so you have been warned. Let's proceed with care. Last time we ended on this probability, win to lose odds equals probability divided by 1 minus probability, and basically this is the formula that links your odds ratio to your probability. So when you hear people say the odds of this team winning are 10 to 1, now you know how to convert that to probability. Basically use this formula. Well, this one actually converts probability into win to lose odds ratio, but we also looked at the other equation that works in the opposite direction. So we'll be using this equation, and let's quickly transform it into this one. So from now on, when we say odds, we mean win to lose odds. All right, now you remember this from way back when we were talking about the logistic regression, how probability is linked to an independent variable x in this case. Well, do you remember the equation that actually described this curve? There it is. So I'll remind you there. That's the equation. It's a logarithm of a p divided by 1 minus p equals b0 plus b1x. So this is in the case of a simple logistic regression. And now let's put the two equations side by side. So this is the one the green one's the one we talked about a long time ago when we were just introducing logistic regression. And the one on the right is the new equation that we now know for the odds ratio. Do you notice any similarities here? Like on the left, on the right, the ratio is actually the same one. So what we can do is take the p divided by 1 minus p and plug it into the first equation as odds. And in that way, we'll get this equation. So this is logarithm of odds equals to b0 plus b1x. It actually has a special name, log odds. So that part on the left is called log odds, and that's just for reference. We won't be talking about log odds at all. We will be focusing on odds because that's what we want to get to the bottom of. Now, this equation is exactly the same for a multiple logistic regression, or just logistic regression in general. So that's what our geodemographic segmentation would look like in terms of odds. Now what we can do with this equation is do a mathematical operation which is called taking the exponent of it. So we'll take the exponent of both sides of the equation, which will give us this. So e to the power of natural logarithm of odds equals e to the power of that whole right part. Now the left part of the equation is very simple. E to the power of the natural logarithm of anything equals that anything which is in the brackets, so basically odds. The right side can be broken down by replacing addition in the power of the exponent with multiplications of the exponent itself. And this brings us to this equation. So this is a very nice and fluffy equation to work with. What we're going to explore is one individual independent variable. So let's just take any random one over here. Let it be b1x1, and let's look at it separately. Now what will happen, and this is what we're actually interested in, this is what we want to find out. What will happen if if we hold everything else constant but we increase x1 by 1 unit of that variable? What will happen to the odds? What will happen to this whole equation? Well, as you can see on the right, if we take e to the power of b1 times x1 plus 1, that is actually equal to e to the power of b1 x1 times e to the power of b1. Now here you can notice that e to the power of b1 x1 is that part of the equation as it was before we increased x1 by 1 unit. So the new part is this part over here, e to the power of b1. That is what happens to the odds. They get multiplied by a factor of e to the power of b1. And this is the part where you shout, Eureka, we've got it. This is what we were after. Now let's put this in writing so that we definitely remember what we just found out. You know how I don't like putting too much text on my slides, but this time is an exception, important conclusion, and we're going to write it out. Increasing an independent variable xi, so any independent variable x, by 1 unit will increase the odds by a multiplicative factor of e to the power of bi. So that's exactly what we talked about here, that if you increase x1 by 1 unit, then your odds will actually get multiplied by e to the power of the coefficient of x1, which is b1. Very, very important conclusion, very, very insightful. And don't forget, we're not talking about probability, we're talking about odds here. So the odds that we discussed in the previous tutorial. So now let's look at an example. This is our model from previously, the model we built for our geodemographic segmentation. And here we've got a variable called age. Let's look at what happens when we increase age by 1. So as per our conclusion, the odds will increase by e to the power of bh. Bh is the coefficient of age here. So that means e to the power of 0.0726550, and that equals to 10754. So this means that whenever you increase age by 1 year, so if you take 2 people and hold everything else constant, all of the other variables, credit score, number of products, is active member, the gender, the country, the tenure, and the logarithm of their balance, if you can't hold those other variables constant, but one of those people is older by 1 year than the other, then the older person, their odds of leaving the bank increase by 1.075. So they get multiplied by this factor of 1.075. So what does that give us? That gives us 2 things. First of all, we now know, as actually we did previously, that if you increase age, the odds will increase, meaning that the probability will increase, because we remember that if odds increase, probability increases. If odds decrease, probability will decrease. But the second, the more important thing is that now we have a quantifiable metric to tell by how much exactly the odds will increase, how many times, what's the multiplicative factor. And that is very powerful because it will allow us to compare the different independent variables and their contribution to this model. And we'll do that, we'll start doing that in the next tutorial. And I look forward to seeing you next time. Until then, happy analyzing. Alright, done with the math. Hope you survived that. Hope you powered through and got some valuable insights and knowledge from the previous couple of tutorials. And today we're off to the fun part. We're going to work with Gretel. We're going to recreate our model, and I'll show you how to get the odds ratios for your coefficients in your logistic regression. And then I'll show you how to take them and export them into Excel. And then actually I will show you how to put them into PowerPoint, and I will show you the way I would go about presenting them to a manager or to an executive and so on. So the knowledge that you'll gain in this tutorial will be applicable regardless of what tool you're using. Just like everything that we're learning, regardless of what tool you're going to be using for modeling, you're going to be able to apply this knowledge in your work. All right, so let's get straight into it. So I've already got Gretel open up somewhere over here. There it is. And before you do anything, don't pause this video. Before you do anything, before you recreate the model just like I did, you have to do one other thing. Otherwise, you'll have to do the work twice. And so just go to File, and we're going to install a package. I'll explain what I'm doing now, and then you'll recreate the model. So don't create the model for now. Just watch this explanation. So if I go to Model and I run the model, so I've already done the coefficients here, and everything is ready to run. If I run this model now, you'll notice that it doesn't have any information on the odds ratio. So this is like we're used to seeing, what we're used to seeing, but other packages, other software packages for modeling, they will add another column over here which tells you about the odds ratio. So it already knows that you want to take the exponent of the coefficients, so it'll do that for you and add another column. Gradle doesn't do that, but there's a workaround. We can install a package that will help us get that information. So just close that. Well, I'll close that. Before you create the model, what you need to do in Gradle is you go to File, actually go to Tools, go to Function Packages, go to On Server, and here scroll down and find a package which starts with the letter O and it's called Odds Ratios. So once you found that, it's by Ricardo Jack. So once you've found that, click Install, right click and click Install. It's installed. My one doesn't ask me to restart Gradle because I already had it installed, but yours will ask you to restart Gradle. So that's why I warned you from creating a model, because you would have to restart Gradle and you would lose all of that. So once you've installed it, restart Gradle and then we'll create the model. Alright, now assuming that you've installed the package, go ahead and import your dataset, which is churnmodeling.csv. And as we did previously, create the dummy variables for geography, for gender, and create this new variable log balance, which is log 10 balance plus 1. And now we're going to go run the model. So model limited logit binary. And as you can see here, I already have the variables. And I use that file that we saved a while back to remind me which variables we decided to keep. And I've put on show p-values. So just copy them from either that file or from my screen. And once you've done that, click OK. And here we have the model. And as we had it previously, right? But now we know one extra thing. We know something special about the coefficients, that we can now interpret them. And isn't that a bit exciting? So what we can do with these coefficients, we can take an exponent of the coefficients, and that will tell us how the odds ratio is impacted when you have a 1 unit change in the underlying variable. Now we don't have that column as discussed, but after you've installed the package, if you go to Analysis, there'll be a new menu here, which is Logit Odds Ratios. And if you click that, you will get the odds ratios. So basically the multiplicative factors that will be applied to your odds ratio if your variable, the underlying variable, is increased by 1 unit. So this is the really cool part. Now we get to take all of this and put it into one Excel spreadsheet, preparing it for our report. So there's Excel. What I'm going to do now is I'll move it here somewhere. I'm going to take all of this. I'm going to go File, Edit, actually, Copy. And I want to copy it as this comma separated. Okay. Copied there. Perfect. Now I'm going to take this and I'm going to, there has to be a button there, copy. Just plain text is fine. And I'm going to paste it somewhere here. Right? So now I'm going to select this column. So I'm going to zoom in a bit for you to see better. Alright, so pretty much we've taken all the information about our model from Gradle and we've put it into Excel. Great, now let's make it look pretty. I'm going to select this column just for this odds ratio stuff, because as you can see, the information here is in each cell, just a long line of information. Select the column. I'm going to go to Data, Text to Columns, our favorite. We'll go Delimited, and we'll just select space. Forget about tab, select space, make sure that is checked. Treat consecutive delimiters as 1. Next, and just click Finish. There you go. So now it's all separated. Great. Now we have these variables, right? Don't forget there's no constant, just starting from the variables. Take the odds ratios, copy them, and put them here. Not the constant, the second line. And don't forget the name. Put it over there. All right, great. So now we can get rid of all of this. Delete that. Now we can get rid of all of that. Delete that. Get rid of all of that. Delete that. Okay, so this is us preparing a report. This is the fun part. We're preparing a report for the manager or for the executive, or whoever you're presenting to, an audience of 10 people. You want to explain to them how their bank is performing, why are people leaving, what has this test done, what has it told us, and what are the steps going forward, what should the bank focus on. So obviously they're not going to be interested in standard error or the Z value, so we can get rid of them. The less information, the better. People digest smaller chunks of information better. You might want to keep the p-value just as evidence of your approach of, that these are statistically significant variables, and then maybe you'll have a chat about the tenure that it is greater than 0.05, but you decide to keep it in, and there is a red flag there that this is, that it's doing the opposite. So basically, we'll just keep them in, but we'll gray them out. We'll gray them out so people understand that this is not actually the most important part of the report. What is important is the coefficient and the odds ratio. And as you now know, the odds ratio is directly linked to the coefficient. It's the exponent of your coefficient. You can actually, we could have done this without the package. We could have just gone in Excel equals exponent of that, right? And just copied it down. And so you can see it's exactly the same value, So why I did it through the package is because other software modeling packages, they actually give you this column. So I wanted to, you be comfortable with having this column in here already. So we have this column. What can we do with it? Well, let's do the most important part. We're going to go to home, and here we're going to do conditional formatting, color scales, and let's just select this one. Right away, we can visually see a heat map, and we can see what is going on. We can see right away Germany, bam, it is the highest impact for people leaving. So green in this case is we actually need the reverse heat map. So that's good that we noticed that. So let's do the reverse heat map, so the second one. So people in Germany are the most likely to leave. So this is, well, the way this works, probably the best way to say it is, this is the most important factor, the most important independent variable that influences people leaving, right? So if you change from not Germany to Germany, then the odds ratio increases by 2.1. Basically, the odds ratio doubles. Then next one is gender. So when you go from a male customer to a female customer, all else held constant, female customer is the odds ratio of a female customer leaving are 1.7 times greater than for a male customer. So basically the odds ratio increases by 70%. That's huge. And then is active member is the opposite. So here you can see it's less than 1, which means that when you go from a member who is not active to a member who is active, the odds ratio gets multiplied by 0.34. So it basically drops by 66%, which is also a great result. It's a great result in terms of retention, keeping the customer. Then these are yellow, and anything below 0.8. So this is actually a good rule of thumb for you here. Anything below 0.8, you don't include it. So it's not that important. It doesn't have that much of an impact. Anything above anything above 0.8 and below 1.2 doesn't have much of an impact. So you can kind of ignore those variables. So the odds ratio here gets multiplied by 0.98, or here it gets multiplied by 1.07. So not that much of a change. If you want to, you can explore these further, but what this heat map is telling you that these are your alarming red flags. You gotta focus on these. This is important, so you try to make your members more active. And you have to cater to the German market, to female customers in the German market. Something's going on there. So that's the important part. And that is what you're going to be presenting to your executives. These are your key findings. Remember, data science is about finding insights from the data. These are your insights. Another thing I wanted to show you here is that because we're taking an exponent, you know that e to the power of 0 equals 1. So if you have a 0 here, it'll be exactly 1 here. Anything below 0 here will be a value less than 1. So a negative means less than 1. A negative, less than 1. Negative, less than 1. Negative, less than 1. Anything above 0 will be a positive value here. So positive and greater than 1. So anything above 0 will be a value above 1 here. Positive above 1. These are positive above 1, positive above 1. So just showing you that there is an alignment between the sign here and whether the value is greater than 1 or less than 1 here, which is as we expected, right? So now we're going to take this, and I've actually got a report prepared here. So this is going to go to your manager, or to our manager. And I'm going to just increase the size a bit, make some space, zoom out. Let's copy that and let's paste that in. So there's our report. Maybe where's view, grid lines? No. So there you go. So that is the report that you'll be sending off to your manager, and maybe you can add some footnotes saying, okay, these are the insights. Active members, least likely to leave, and very, very impactful metric. So we want to try and make our members as active as possible, get them working with our bank, right? And then there's something going on in this geography with female customers. Perhaps they're not happy with the products that we're providing, or there's a competitor that is targeting them, so we have to do something about it. And then these ones, you would only look at them next. So probably this one is the next important one, number of products. So if people have more products, they're less likely to leave, as you would expect. So there you go. That's how you analyze the coefficients of a logistic regression, and more importantly, a geodemographic customer segmentation. I hope this tutorial was useful, very insightful. When I learned this for the first time, it was like mind-blowing. It took me a while to get my head around it and actually understand how to use it. I kept forgetting how this odds ratio was derived, because there is there's quite a lot to remember, I understand, but you can always come back and refresh this knowledge if you forget. But do also know that you can use this in your modeling now, and I hope that this information will help you in your work. And I look forward to seeing you next time. Until then, happy analyzing. Section recap. So what did we learn in this rather intense section? In this section we learned, number one, ranking dimensions. So we saw how our model has provided a new dimension which we can use to look at our customers. That dimension is their ranking in the model, their probability to leave the bank or perform a certain action, and that allows us to drive additional insights or segment our customers, create deciles, quartiles, and so on to better service our customers. Number two, how to draw insights from the cumulative accuracy profile. And specifically, we looked at two types of insights. Number one, if you have a budget constraint, what do you do? How do you find out the people you contact, and how do you talk to the manager of the department that's contacting these people? How can you say exactly what the return on investment will be for that budget? And two is efficiency. So sometimes you don't actually need to contact everybody to get a good and efficient outcome. So basically, you can save a lot of money, or maybe focus on other things and deliver a better customer experience, because you're not bothering people with too much emails or contacts. And by the way, just to clarify, we are talking in terms of customers and a customer geodemographic segmentation. But as I mentioned a couple times throughout this part of the course, all of these principles are also applicable in other industries, whether it's a factory that's producing toothbrushes, or it's a fraud investigation, engagement, anything. So just basically replace your independent variables with the correct observations that you are interested in, or correct effects that you're looking for, and you'll get the basically the same result. They're numbers after all, right? So it doesn't matter what form they take. It matters how we deal with them and what insights we're able to produce. So just keep that in mind, that it doesn't have to be a customer geodemographic segmentation model. And number three, odds ratio. So this was one of the advanced topics. This is where they started. We talked about the odds ratio and how it links to probability. Then we talked about how you can actually interpret the coefficients of logistic regression. It's not as direct and straightforward as in a multiple linear regression. That's why these topics were advanced, because we had to go into a bit of math, but we did find out how a 1 unit increase in an independent variable of a logistic regression actually translates into a change of the odds ratio for the probability of the event occurring. And number five, we looked at the practical application. So I gave you an example of how I would go about presenting my findings in a logistic regression to a manager or to an executive of the company, and how to really visually portray your findings using a heat map. So that's all for this section. Hope you enjoyed it. Hope you had fun and learned some valuable knowledge here. And I look forward to seeing you in the next section of the course. Until then, happy analyzing.
Welcome to the section on model maintenance. I put this information as a separate section because I believe that model maintenance is often either overlooked or underestimated. And organizations that just start into modeling, or data scientists that are new to modeling, often don't have a strict step-by-step procedure that they follow once in a while in order to make sure that their models are robust and still performing at their best. And in this section, we'll talk about why models deteriorate over time and what you can do in order to make sure that they are at their peak performance even 6 months down the track, 12 months down the track, or 2 years down the track. So let's get straight into it.
Model deterioration. This is going to be an exciting topic, maybe even unique on the whole internet. I'm not going to claim that, but maybe, because I haven't seen it anywhere else. We're going to find out how models deteriorate. What does it look like when a model deteriorates? All right, so we have our CAP curve. Our CAP curve is a very powerful tool that allows us to see our model, to have a graphical representation of our model, which includes as well how well the model is performing. And remember, we had this still rule of thumb that you look at the 50% and you see where it crosses your model line, where your CAP line is crossed by this vertical 50% line. So, and that allows you to determine how well your model is performing, how good this model is. And we had this rule of thumb where anything below 60% is a rubbish model, anything between 60 and 70 is a poor model, 70 to 80 is good, 80 to 90 very good, 90 to 100 too good, practically very unlikely that that can be achieved. So let's observe a model over time and see how it will deteriorate. It's going to be fun. All right, so we start off with our model, and at the top, in the top left corner, we're going to say how old it is. This is a brand new model. You've just delivered it. You're very excited about it, very proud, and it's performing at 81% at the 50% mark. So it's a very good model. And let's see what happens to it next. 6 months down the track. How well is it performing? A bit worse, 75%, so it is just a good model. It's not a very good model anymore, it's just a good model. But still pretty solid. It's giving good results, good predictions. You can drive value from it. Then 12 months down the track. What do we see here? 69%. It just crossed into the poor path or the poor threshold. So as you remember, 60 to 70 is kind of like a poor model, but it's still around the 70% mark, still maybe driving insights, not as good as when it was brand new, 81%, but it's kind of still doing alright, fairly alright, but venturing into the poor territory. Another 6 months down the track, after 18 months after deployment, how well is our model doing? Only 63%. That is definitely a poor model. Can't really derive a lot of value from that. But, we are not maintaining it, so let's see what happens 6 months later. 24 months down the track, 55%. And that is already a red flag, a warning. 55% is not much better than a random coin toss. Just a 5% increase on top of a coin toss, and like, what's the point of having that model? What's the point of wasting processing power and actually using it in business processes? This is kind of already useless. That's why we call them rubbish models. Total rubbish model. And believe it or not, 6 months later, even this can happen. And I've actually seen one of these models where it's driving negative value for the business. 42%, when if you use a random coin toss, you'll actually get a better result. Definitely this model is not just rubbish, it's actually doing worse for the business. So that's how a model can deteriorate over time. The timeframes used over here are completely out of the blue, so it might not be a 6-month period between each one of these. Might be 12-month period, might be even 3-year period. Depends on the industry. It could be faster, it could be a month, it could be 2 months. Depends on the dynamics in the industry, in the company, in the population, in the country, in the economic environment, and so on. So depends on what you're modeling as well. So if you're not modeling populace like people and your customer base and so on, if you're modeling defects at in a factory, then your model might last longer. But then if something changes, for instance, the plastic or the materials change, then your model might start deteriorating. So it all depends on the circumstances, but models do deteriorate over time, and we'll actually find out why in the next tutorial. Hope you enjoyed this one. I definitely found it quite visual, and hopefully it illustrates the concept of model deterioration quite well. Why do models deteriorate? Now this is going to be an interesting tutorial because I can't just simply give you a blueprint or framework here, because there can be literally a myriad of reasons why models deteriorate. Nevertheless, we're going to throw around some ideas so that you can see which way to think when you see deterioration in your model, so maybe you will find the reason. Alright, so we saw that a new model in 18 months can easily go from 81% in our rule of thumb assessment to 63%. What could be the reasons? Well, let's have a look at some possible reasons. Additional factors. For instance, your model includes only some variables, and then there is actually another variable that appears that your model doesn't include. A good example would be, say, in a factory, you've got a model that predicts defects, but then you add a new component to your element that you're producing. So whether it's a toothbrush or something else, whatever you're producing, a car. So you've added a new variable, a new component, but that variable is obviously not included in your model because your model was built before that variable was added. Another one could be changes in behavior. So if we're modeling the behavior of human beings, like in the example of the bank, people might change their behavior. Why they change their behavior, that's a different question. It could be a result of something else. So that's like another effect that caused the change of the behavior. For example, when smartphones came out, they became so popular very quickly that maybe people started banking with their smartphones and they don't like the color of your bank's app, or your bank doesn't have an app, something like that. Changes in process. So going back to the factory example, maybe now your toothbrushes are being produced in a different way. So maybe you've changed the conveyor belt somewhere, or maybe you have excluded an additional step from the actual process of manufacturing, and that wasn't taken into account in your model previously, and now it's not performing as well. Changes in existing factors. Going back to the example, we're jumping around with examples here. Going back to the example of customers in a bank, maybe the distribution of ages of your customers changed. So with time, this is a good one. With time, customers get older, and maybe, obviously not as quickly as 18 months, but maybe over a couple of years, your customer base has gotten older and you haven't done anything to maintain that distribution curve as you had when you created the model, and which can be fine. Maybe you're not aiming to get younger customers. Maybe you started as a young bank, a new bank, and then your customers naturally aged over the period of 5 or 10 years, and now obviously their behaviors are different, the distribution of their age is different, and therefore your model hasn't been adapted to the new customer base. So that could be a reason. That's actually a good example because people get older with time, models will also get older, and people's behavior changes, and also the actual distribution of the variable age has changed, whereas the model is expecting a different type of distribution. So there you go, that could be a reason. Competitor, maybe a competitor entered the market, or multiple competitors have been entering the market and they have been changing things, or they've been taking a share of your customers, and more customers have been leaving disproportionately more to what the model is expecting. Changes in the industry, that also could be to do with competitors, or maybe something, say a new product has been introduced in the industry, or maybe there's been a lot of consolidation in the industry, and now there are major players that are that customers are gravitating towards, or the opposite. Maybe companies have broken down into little ones, or maybe there's been acquisitions or mergers or something like that, something in the industry, you would know this if you have the intrinsic knowledge and you on top of things and something changes drastically or even slowly over time, but still drastically, you would hear about it and you would think that maybe that is causing the changing model. You will know what I'm talking about when you come across it. When you see a change in the industry and you see it affect your model, or you see a change in your model, you will link the two. It's sometimes very obvious when this happens. Changes in regulation. That's a good one because it can actually really impact a model very quickly. Let's say something changed in the regulations overnight and now a process has changed. The way you do things has become different. For instance, previously, in order to get people to perform an action, which you're measuring with this model, you had to send them direct mail. So you had to send them physical mail to get them to do something. Let's say it was to get their phone number. You don't have their phone number and you want their phone number, and this model is predicting the likelihood of people giving you their phone number. So previously, according to regulation, in order to get their phone number, you had to send them direct mail physically. But now the regulation has changed and you can send them electronic direct communications, right? EDMs, and they can reply by email and give you their phone number that way. Of course, it's going to be easier to get their phone numbers, and therefore your model is not going to be performing as well because it's not used to this drastic change. It's built for direct mails, or direct communications. Now you're sending electronic direct communications, completely different situation. You have to rebuild the model. Changes in product. That's another one. Maybe you're predicting how likely people are of uptaking a certain product, and then you release another product which is cannibalizing the demand for the first product. So you're kind of competing with yourself, and the model doesn't take that into account. So the model was built in the circumstances. What we're trying to understand here is that, or the message I'm trying to convey is that a model is built in a certain environment. It is nurtured, grown, and deployed in a certain environment. If the environment changes, then the model might break. It might stop working. These things are very fragile. They can only work. They're very powerful and strong when they work in the environment where they were created. As soon as something about the environment changes, the models can deteriorate and even break. Depletion. That's an interesting one. If a model over time has used up the customers or the elements that it's modeling, so it's kind of a vicious cycle here. So it doesn't apply always, doesn't apply to all models, only some situations. So when, say, you want some action which is a one-off action, you can't get that person like a repeat purchase, or you don't even need to get him to do that action. It's like the example of providing a mobile number. Once you have the mobile number, that's it. That person's out of the equation, and perhaps your customer base is not growing that quickly, and say you created a model on a small sample, like 10,000 people. You created this model, and then you want to apply it to your whole population. Well, after you've applied it once, and you've sent out the communications to get those phone numbers, and you've gotten them from the most probable people to give them to you, that's it. If you apply the model again, your population has changed, right? You're not going to apply it to those people that already gave you mobile numbers. You're going to apply it to those that didn't, and therefore your model is not going to perform the same way because you've already depleted that potential for people to give you mobile numbers, which is actually a good thing. So you've actually gotten the phone numbers. Just the thing is that you can't reapply the model in that case. So situations like that can occur. Be careful of those. And number 10, what I think of here, spontaneous changes. Okay, this is an interesting one. Something in the industry, company, behavior, regulations, product, any of these happened like very, very quickly and unexpectedly. And why I brought this one up? Because I wanted to show you as a bonus 2 additional examples of model deterioration. These are going to be a bit weird, and they're going to be funny, and they're going to be a bit challenging to understand. So let's go ahead. So example number 1 is this one. What do you think happened here? What does this look like to you? It looks weird, right? It's you wouldn't think that the red line can be both above and below the blue line. But let me explain what happened here. And I'm going to use my mouse for this because this is important. So when you see something like this, obviously something happened, something went wrong. It's not just like gradual deterioration like this over time. This was like a spontaneous kind of thing. So what actually in fact happened here is the way kind of to determine this is look at the area under the chart. Remember long time ago, a couple sections ago now, we were talking about the correct mathematical accuracy ratio is defined as the area under this model over here divided by the area under the perfect model, which we can't see over here. And what we're using is just a rule of thumb because it's faster and it's very visual. So look at the area under the curve here. What do you see? You see that the area under the curve has decreased, right? So there's a less area under the curve. What this is telling us is that the model is not predicting as many churners. And in this particular case, what exactly happened is the number of churners drastically increased. And if you, this might be a bit weird to look at it this way, but look what's happening. So the model's predicting, still predicting, even though it's going under the blue curve, doesn't matter. It's still predicting that people are leaving. So as this is growing, you're growing here. So as long as you're going up here, that means you're getting more churners or more people that actually left. And so as it gets over here, then you have this drastic move, bam, very quickly. So basically here, every single time you take a person from the horizontal axis, you're picking up a lever, an actual churner. Then you pick up another person, he's also a churner. So here, it's every single time, it's spot on, you're hitting a person that's leaving. And then it starts predicting again with some sort of rate. So what this is telling us is that before it looked like this. Before there was just a normal curve here. So as you were picking up like a certain number of people, some of them were churners, some of them were like people who left the company, some of them weren't. But here they all became leavers of from the company. So what this is telling us is there's something drastic change in the industry, that all these people that used to be here now all of a sudden have left, or all of these people that all this classification, the people that were placed here according to the model's classification have now left. A good example of that is a categorical variable, like let's say country. Let's say we have 3 countries, right, in our data set, and let's say all of these people are from Germany, then these people are from France, and these people from Spain. Of course, the model doesn't do that, but if there is a very distinct difference between the regions, they might end up grouped together. So if everybody from Germany is much more likely to leave than people from France, and they're much more likely to leave than people from Spain, then that's how the model is going to structure it. So the logistic regression will put people from Germany at the start, then people from France, and people from Spain. And then what happens here, everybody from France decides to leave the bank. That's it. Maybe that's a good example of change in regulation. Maybe they're not allowed to bank with your bank anymore. That's it. Your bank has been prohibited of working in France. Everybody in France is going to leave your bank. And that's what we're seeing here. That's why as soon as the model gets to the people that it previously placed in this part, which were all from France, and were kind of like at moderate risk of leaving, now they're all leaving spontaneously. And as you can see, that is blowing up the model. So what would you do in this case? Well, first of all, if you know the exact reason and you can see that there's this categorical variable, of course you would exclude it from your modeling because you would treat them separately. You would treat the population of your bank or the people that bank with you in France, you would treat them separately because there's no point in modeling them. They're all going to leave anyway. You already know that. What's the point in putting them in a model? If it's not such a drastic change, you just rebuild the model and you would try see how that can be accommodated by the model. The other one we're going to look at is also a bit weird. What do you think happened here? And this is a great example actually of the fact that you can't always use the rule of thumb. You can use the rule of thumb when models are like normal, like that. When this happens, look at this model. So here you can see that at 50%, this is, by the way, this is the same model. This model is the same as this model. And what you can see here is that at 50%, this model is actually predicting a lot more. So like nearly 89% of churn. So this rule of thumb assessment has gone up really well. So this looks like a much better model if you assess it that way. But what is happening in reality is if you get over here, you see the model's predicting, and then once you get over here to these people that were placed somewhere between 60% and 80%, so you get to these people, you're not picking up any leavers. None of them are actually leaving the company, or none of them are performing that action that you're measuring. So similar to this situation, but the opposite. Here they all decided to leave. Here everybody in France decided to stay. Once again, could be a regulation, could be a new product, could be maybe there were only 2 banks in France, and one of them just closed down, and that's it. You're the only one, so everybody had to stay with you. It could be anything like that. But once again, in this case, something happened, something major happened, and you can see that your model broke. So in this situation, I wouldn't measure it with this rule of thumb. In fact, I would do something about this categorical variable because it is definitely doing something wrong to the model, and also you have to rebuild or retrain the model. Speaking of rebuilding and retraining, that's our next topic. Now that we know what it looks like when models deteriorate and why they can deteriorate, it's about time that we talked about maintaining our models and making sure that they're nice and fresh all the time. And we will talk about that in the next tutorial. Model maintenance. We've been leading up to this tutorial in the previous 2 where we talked about how models deteriorate and why they deteriorate. And today it's time to understand what we can do to prevent them from deteriorating, or at least find out that they're deteriorating on time to replace them. And I'm going to cut straight to the chase here. This is the process that I'm going to be talking about. It's called the RR process. That is my own abbreviation, ARR, and we're going to go through every single one of these letters one by one. And the way this process works is it's a hierarchical process. So first you do the first letter, A. If that works, then you're good. If that fails, then you move on to the next letter, R. If that works, then you're all sweet. If that fails, then you move on to the last step, the last R. So let's find out what they are. A. A stands for assess. This is by far the most important part of the model maintenance cycle. You have to look at your models. Periodically, you have to assess them and see how they're going. You can't just leave them alone and hope for the best, or wait until they tell you that they're not working, because that's not going to happen. You have to take your models and once in a while run a fresh sample through them, and for one that you already know the outcome, say take another 1,000 people randomly selected from your bank, or 1,000 toothbrushes sampled, or a couple thousand, and see what happened there. Like, you already know the outcome. You already know whether or not those people left, whether or not those toothbrushes were faulty, and but run the data through your model and see what it would have predicted. Create the cap curve, check the rule of thumb, see how much worse it is than the original model that you created, and determine for yourself, are you happy with that or not. If you're happy with that, great. Your model's doing fine. Let it keep running. If you're not, you got to move on to the next letter. Next letter is R for retrain. So this is the point where you're not happy with how your model is performing. It's the cap curve is flattening out, and you got to do something about it. So retrain implies keeping the variables that you've already selected. So in retrain, you don't have to do that whole process that we went through. You don't have to throw everything, take all the variables that you have in your company, throw them at the models, obviously select them logically, but then still throw them at your model, and then do the backward elimination process, and then find out the coefficients. You don't have to do all of that. In retrain, you keep the variables that you've already found out. Like, for instance, we decided we'll keep the dummy variable called Germany. We'll keep the dummy variable for gender. We'll even keep tenure, but we'll exclude other things from our model. And all you have to do, since you're keeping the variables, you just have to give your model a fresh sample to train it on. So what will change is the coefficients. The coefficients of your logistic regression will change because you've given your model a fresh sample. Of course, you'll have to have training data and test data just like we did. And once you've used the training data, then you check your model on the test data. And if the cap curve improves, then from there you deploy the new model or the refreshed, retrained model. That's what it's called, retrained model. You deploy the retrained model and maybe you monitor for it for a bit, a bit more frequently. So instead of if you are monitoring your models once every 6 months, this one you might check up on it in 2 months, and then in 2 months again, and then 2 months again, because it is kind of on probation. It's a new thing. You've retrained the model, but that might fix the situation. That might be sufficient, and that might happen when your variables are still explaining what's going on. It's just that the coefficients are not sufficient. For instance, let's say age is a important factor, and also tenure is an important factor, right? But in our model, age was way more important than tenure. But let's say that over time things change, and they're still both important, just that tenure has become a bit more important or much more important. And now the coefficient for tenure has to be greater, but your model hasn't had a chance to understand that. You have to give it some fresh data and train it on that, and maybe that it'll pick that up, and maybe it'll start working well from there. So if that gives you a cap curve that you're satisfied with, then perfect. Keep that model and continue going down that path. But if that fails, then you have to move on to the last R, which is rebuild. You have to rebuild your model from scratch. And we're talking about everything. Completely scrap the model that you have, or if it's not doing that bad, if this is like a preliminary phase, and we'll talk about this in a second, then don't scrap it completely. But basically what you have to do is go all the way back, find the variables, do this whole process again, and get a new model. Now, speaking of this whole scrapping business, sometimes if your model is performing really poorly or it's rubbish, then of course you have to scrap it and build a new one. But if you're doing this model maintenance process right, then you'll pick up the fact that it's deteriorating on time. You'll pick it up early, and the model's not working poorly yet. It's still doing a good job, but you just want to see if you can do a better job with a new model. So in that case, once you build the second model, you run them side by side. And this is called a champion challenger setup, where your existing model is the champion and your new model is the challenger. And you're running them side by side, and you want to see which one performs better over time and basically in real life situations, and then you'll keep the one that's performing better. And you can do this in different ways. You could run the champion challenger and only use the output of the champion, or only use the output of the challenger, but just monitor them at the same time. Or you could actually split your population in half and run half through the champion, half through the challenger. It's up to you how you set this up, but that is a good, valid approach to make sure that if you are going to replace your model, that you're not replacing it with something that's actually worse. And that's basically how you do model maintenance. Remember to do it on time. sounds like a car maintenance, right? Don't forget to do your car maintenance. But it is a fair point. You should do your model maintenance on time. You should schedule it. Frequency depends on the industry, depends on what exactly is you're modeling. It can vary. It can be 3 months, 6 months, 12 months, 2 years. But I would actually, that is the frequency of when you need to update the models. I would actually assess them at least every 6 months. So at least once 6 months, you go ahead and just quickly assess your model. It doesn't take that long. And then maybe if things are changing quickly, or you're in a very fast-paced environment, a business environment, then maybe assess your models once every 3 months or so. Too frequent is also, there's no point in that. So assessing a model every day is definitely doesn't have a point. But you will gauge over time what is the right frequency for your environment and for your specific models. Just don't forget to do it because it's really sad when somebody deploys a model and it deteriorates over time and nobody picks it up on time to fix that or replace the model. So there we go. That's how you do model maintenance. Nothing complicated. Just a 3-step process, ARR. And that brings us to the end of this tutorial. I hope you picked up something useful, and hopefully this will help you in your day-to-day role. Section recap. So what did we learn in this section about model maintenance? First of all, we saw what model iteration is and what model iteration actually looks like. And I think that that was very important for you to see how that will look in real life so that you can easily detect the situation when it occurs. And I think we really drove the point home with those interesting visuals that we had in that tutorial. Number two, why models deteriorate. So we looked at why they deteriorate over time, then spontaneous iteration. So although there is no blueprint here, there can be myriads of reasons why models deteriorate. We still threw around some ideas that will help you understand why a model is deteriorating if you do come across this situation. Then we talked about the 3 levels of model maintenance, or the ARR process. Assess, retrain, rebuild. It's not a complicated process. All you have to do is make sure that you assess your models quite frequently, at least once every 6 months, maybe a bit more frequently in some industries and for some types of models. And then we talked about the champion challenger setup. So if you do decide to build a new model and your old model is not performing too poorly, then you might want to run them side by side to see if the new model is actually performing better than the old model in real life situations.
What is working with data? In order to get from raw data to insights, your data has to undergo a journey. And broadly speaking, this journey consists of 4 major steps. These are ETL, database, analyze, and visualize. Now, analyze and visualize are pretty straightforward. These constitute the creative part of the work of a data scientist. Whereas working with data comprises of the ETL and database steps. And this is what we will be talking about in this part of this course, and visualize. And so this is why this part of the course is so voluminous and also so important.
Data warehousing simply means storing the data in a relational database. However, the term data warehousing implies that this is not a transactional database. Rather, it is specifically designed to store data that will be analyzed and visualized to derive insights. So here, your relational database, as the name suggests, is one where the relations between data within the database matters. In simplest terms, let's have a look at some of them. Number 1, integrity. While in Excel, every cell is separate and you can place anything you want into it, for example, date, a number, a text, and so on, in a database, columns have predefined types. And therefore, if your column is designed to contain numbers, it cannot contain a text, or it cannot contain a date or any other type of information, and vice versa. The second advantage is that combining datasets in a database is easy. That is how they are designed. As you will see further in this course, it is very natural to join tables, to create new tables, and derive insights. On the other hand, in Excel, you would have to use tools like the VLOOKUP function, which is much more complicated and much less efficient. And a great plus of databases is that they are easily scalable. You can have 5 rows or 5 billion rows and it won't crash. Whereas Excel is much more limited in that sense, and its performance becomes much slower as your dataset grows. There are more advantages of databases which we won't go through at this stage. You will discover them as we progress through this course. And to sum up, databases are the next level up from Excel. Once you get a grip over databases, you won't want to use Excel anymore. By the way, here's the icon that represents databases on diagrams. Get used to it because you will be seeing it quite often. And to finish off today's tutorial, in this course we'll be working with SQL databases. SQL stands for Structured Query Language. That is because to manipulate data in this type of database, you need to write queries. For example, this code was used to display the table you saw in the previous slide. But don't be worried, the SQL scripting language is very simple and you will see this from further tutorials in this course. In this tutorial we're going to install SQL Server onto our computers. And if you already have SQL Server installed, or if you're doing these exercises at work on your server there, then feel free to skip this tutorial. However, do have a look at the next one where I explain the importance of creating a test database and how to talk to your database administrator at work to make sure that you can set up a safe environment where you won't damage any of the existing databases and tables by doing these exercises. To start off with, you're going to need a browser. Go to Google and search for SQL Server Express. And then just click on the top link. That should take you to the right place. Now bear in mind that this website changes all the time and it might look different at the time you're taking this class, but never mind. As long as you can get SQL Server Express, that is great. And here you can see that the Express edition is the free edition. It's free to use. It has limitations in terms of capacity of the database and how much RAM it can use and so on, but that doesn't really concern us because we're going to be using it for education purposes. And here you can download SQL Server. Before we proceed, I would like to say that we are going to be working with SQL Server 2014 in this series of tutorials. If there's a later version when you're watching the class, you can go ahead and take that one, although it would be a bit more beneficial if you had the exact same version that we're working with here, so you can probably search for it up at the top. But nevertheless, just go with the version that you find first. For instance, if it's the latest one, go with that, and just click download over here. You will need a Microsoft account, so if you don't have one already, just create an account. It's very easy to create, so you can click sign up now. I'm just going to use my account. And here in this download section, what is very important is for you to select the right version. So for us, we need SQL Server. We definitely need the Management Studio, but this, if you download Management Studio by itself, you will just get the Management Studio, whereas you need the database engine as well. So we are going to go for SQL Server 2014 Express with Advanced Services. So the name at the time when you're downloading this program might be a bit different, or the description might be a bit different. In essence, what you're looking for is both the database and the Management Studio. And on top of that, there's some additional features that we will be requiring in other sections of this course. So just download the most advanced version that you can find, and do make sure that you're downloading the right one for your type of system. So how to find out whether you need a 32 or 64-bit Studio? Very easy. Here's my computer icon. If I go and right click on it and I go to properties, here you will see that it tells me that I have a 64-bit operating system. If yours is 32, then you will need the other version. So I'm just downloading the 64-bit operating system version, and in English. Here just uncheck all these subscriptions, click continue, and that should start your download. And bear in mind that this is quite a large file. I think it is 1.3 gigabytes. It will take quite some time to download, so maybe get yourself a cup of tea. And I will fast forward this tutorial, and we will continue once the file is downloaded. Okay, so once the file is downloaded, it will look like this. And if you double click it, what it will ask you is where it should extract the files. Here you can specify where you would like to extract your files, and once the files have been extracted, then the installation process will begin. Okay, now we're installing SQL Server onto our computers. After this window pops up, you need to select the first option, which is New SQL Server Standalone Installation, and that will start the process of installing SQL Server onto your machine. Okay, so this is going to be quite a lengthy process. About half an hour it takes to install SQL Server. Here you've got the license terms. Just have a look through them to make sure that you agree with everything, and then check the box that you accept. Click next. Here Microsoft will conduct a few checks on your computer, and then it will proceed to some other menus that you will have to also look through. The installation process is quite simple. You don't need to change anything at all. As long as you downloaded the correct package, everything should be pre-selected for you. I'm just showing you here what everything looks like. Like for instance, local DB does not have to be selected. We won't be needing that in our tutorials in this course. And so from here you just leave all the default options and you click next to proceed. And don't forget to change the root of your directory if you like to. I prefer to keep it the default one. Once again, all options stay as the defaults. Same thing, just keep clicking through. Here just leave it on Windows Authentication mode. Just select the first option, install and configure, and then the installation process will begin. This part of the installation process took me about 18 minutes, so depending on your machine it might take a bit longer, it might go a bit faster. I won't show you the whole installation process. I will fast forward through it over here. There's one thing I did want to mention, that when you get to the end of the installation process, you will see that this bar gets to the end, but that's not actually the end. There's still some things that need to be done, so be patient. You will be notified when the installation process is complete, and you will see a window which looks like this. Alright, so this is the final window. You should hopefully see this on your computer as well, and here it says the status for every single element of the installation, every single feature. So just have a look through them to make sure that everything was installed successfully, and after that you're good to go. Alright, now that SQL Server has been successfully installed, let's have a look and see where we can find it. You will notice that a desktop icon has not been created for this program. And in order to find SQL Server, we have to go through the Start menu. So I would like you to go to the Start menu of your computer, and in the Start menu go to All Programs, and here just scroll down until you find the letter M. And under M you will see Microsoft SQL Server 2014, and if you open up that folder you will see an icon here. You'll see many icons, but you need the one with the yellow database in the top left corner, and so we're just going to right click it and we'll select Send to Desktop, Create Shortcut. And I'll just drag this from my other screen onto this screen, and there you go, that's our shortcut for our server. And so we'll just double click it and see what it looks like inside. It might take a minute to load, especially for the first time. And there you go, so you can see your server name. Of course your server name will be different because it depends on your computer name, and all you have to do here is just click connect, and there you go, so you have connected to the server successfully, and you can expand databases here. And in the next tutorial I will show you how to create your own test database. Just installed, we're connecting to it, and now if we go into databases, you will see here in the Object Explorer window on the left, you will see 3 different items. So one's a folder with system databases. We're not going to look at that for now. And then there's 2 more databases which are report. And to create a database, you just right click databases and you click new database. And so we've got this database DS training table. We're going to go to new query. There's a button over here, or you can just press Ctrl N on your keyboard. This brings up a blank window. And here, just type create table, test table, and then brackets, normal brackets, and here we're going to type in 2 more lines. Nearly done. Name, varchar 100, and then comma, don't forget the comma over here, age, int. Highlight this part of our workspace and click this execute button up at the top, or hit F5 on your keyboard. Now if you go to tables and you right click and you click refresh, you will see your new test table appear here. So that's good. We've got a test table. Insert into test table, and then in brackets we're going to say name, age, and we're going to insert values. Highlight the 2 new lines that we've created and click execute. There we go. It says that 3 rows have been affected. Now if we right click our test table, select top 1000 rows, up there. At the bottom in the results pane you will see a table with 3 rows and 2 columns with names and ages which you have just put in. ETL is an abbreviation for extract, transform, load. Now, the data you want to analyze may be stored in a number of locations. For instance, a database, an Excel spreadsheet, a website, Twitter, a CSV file, a JSON file, and these are just a few examples. You could try analyze the data directly in its storage facility, if that is possible, and certainly you could do that for quick ad hoc calculations such as the sum of a column in Excel. However, for serious data science and big data projects, this is a big red flag. Analyzing data in the source can create myriads of problems and poses lots of threats. For instance, you could accidentally modify the underlying raw data and jeopardize all of your work. And that is just the best case scenario. In the worst case, you could severely impact a critical business process and crash one of the internal systems. What we will learn in this course is how to take this data and put it into a warehouse. As we discussed, a warehouse is a relational database designed specifically to store data for analysis. However, you cannot put the data directly into the warehouse. You need to remove anomalies, bring it to the right format, and so on. As you can see, this is a three-step process and the names for the steps are extract, transform, and load. It may sound a bit overwhelming right now, however, as you will see, in its nature this is a very straightforward process. And even though a lot of analysts and data scientists struggle with ETL, that is simply because they don't have any specific framework to follow and they reinvent the wheel every time. That's one of the gaps this course will help you cover. I will give you a tried and tested framework and I will teach you how to use it in your work. Going forward, ETL will seem like cakewalk. In this tutorial, we will explore business intelligence tools. For our ETL process, we will rely on SSIS via SSDT BI with MSVS shell. Sounds confusing, right? Actually, as you will see just now, it's very easy. And by the way, after this tutorial, you will be an expert in Microsoft acronyms, so there's something to look forward to. Let's look at the acronyms one by one. MSVS stands for Microsoft Visual Studio, and it looks like this. In case you haven't heard of Visual Studio before, it's a great software where you can program in C++, C#, create apps, build software, and much more. We won't be needing all of that. We will only require the business intelligence tools in Visual Studio. Think of it this way. For working with the database, we use SQL Server Management Studio. Similarly, we will be using Visual Studio for managing our ETL process. The reason it's called shell is because we won't be using the full Visual Studio. The shell contains just enough user interface to allow us to work with the BI package. Alright, so we've sorted out the MSVS abbreviation. Let's look at the next one. SSDT-BI stands for SQL Server Data Tools Business Intelligence. Some fun facts about SSDT-BI. It was previously called BIDS, which stands for Business Intelligence Development Studio. Then Microsoft changed the name to SSDT-BI. However, SSDT-BI is not the same thing as simply SSDT. SSDT is used for building databases. It comes with the SQL installation. SSDT-BI is for building SSIS, SSAS, and SSRS solutions. Do you see what I meant about Microsoft acronyms? By the way, you will quite often see SS at the start of an abbreviation. Usually it stands for SQL Studio. And this leads us to the next screenshot. This is how SSDT-BI looks like inside Microsoft Visual Studio. As you can see here, it has three components: analysis services, integration services, and reporting services. Let's have a look at them in more detail. The three components of SSDT-BI. SSAS is the analysis services and it's used for analyzing data. SSIS is the integration services and it's used for the ETL process. And SSRS is the reporting services and it's used for visualizing data. The components are listed in alphabetical order. Let's put them onto our diagram so it all makes more sense. Here's our diagram, which takes raw data and converts it into insights. This journey has 4 steps. SSIS fits in at the start when we do the ETL phase. Then once the data is in the database, we would use SSAS to analyze it and SSRS to visualize it. That's Microsoft's proposed approach, and a lot of BI departments in organizations worldwide use these exact tools. In fact, maybe even your company's BI team works like that. However, as data scientists, we have different objectives, which cannot be met with just these tools. We need more sophisticated tools tailored to our type of work. That's why in the analyze step, instead of SSAS, we would be using tools like R, Python, and so on. And in the visualize step, instead of SSRS, we would use much more powerful visualization tools like Tableau. However, there is some good news. SSIS meets our requirements for the ETL process just fine, and that's why we will stick with it. And to sum up for today, we will be using an MSVS shell to run SSDTBI because we need SSIS to perform our ETL. Hope you're much more comfortable with these acronyms now, and in the next tutorial we will install the MSVS shell with SSDTBI. In this tutorial, I will show you how to install Microsoft Business Intelligence tools. In this course, we will be using a free package distributed by Microsoft. Note that if you have Microsoft Visual Studio, then skip to the last part of this tutorial and perform the check to see if your Visual Studio has Business Intelligence tools integrated. If so, you're all set to go. Alright, let's get on with the installation. To start off, we will need a browser. In Google, type in SSDTBI, which stands for SQL Server Data Tools Business Intelligence. You need the Microsoft link. Here you can see that the latest version of the BI tools is for Visual Studio 2013. I recommend going with that. If you cannot find it and there is a later version available, that should also work. Expand the system requirements and make sure you have the right operating system and meet the hardware requirements. Note that this distribution supports both 32 and 64-bit machines. This will be important for us in an installation step further in this tutorial. In the prerequisites, you will see that these tools require Microsoft Visual Studio Shell to run. If we now expand the additional information section, then you will see that this installation pack actually contains Microsoft Visual Studio Shell. This is great and means that we won't have to install anything else to get the BI tools working. Download the file. This is a big file and may take some time to download. Once the file has been downloaded, you need to extract its contents. This can take up to 10 minutes. After the extraction completes, you will be presented with the following menu. You will notice that it looks a lot like SQL Server installation menu, but don't be worried, you're not installing SQL Server all over again. Select the top option, New SQL Server Standalone Installation. Microsoft will run some checks and finally you will be presented with this installation type selection menu. Now this is the important step. Logically, you would press Add Features to an existing instance of SQL Server 2014. That seems like the right way to go because you have already installed SQL Server Express. However, if you go down this path, you will most likely get an error further down in the installation. The reason is that if you have a 64-bit machine, then you installed SQL Server for 64-bit machines. Whereas, as we noted, the Business Intelligence package we are installing is designed differently. It works with both 32 and 64-bit machines. This difference in architecture will prevent you from combining the two. The correct option here is Perform a New Installation. Read through the license agreement and accept if you agree. Under Feature Selection, make sure that SQL Server Data Tools Business Intelligence and SQL Client Connectivity SDK are selected. I cannot proceed with this installation because I already have the package on my computer. We've done the bulk of the work. Default settings in the remaining steps are fine, so just click through and start the installation. After the installation has completed, go to Start, All Programs, and find Microsoft SQL Server 2014. There you will find a purple icon named SQL Server Data Tools for Visual Studio 2013. Right-click the icon and create a shortcut on your desktop. Here it is. You can launch the program. Great, the program is launched and now we will test if the BI tools are installed correctly. Go to File, New, Project, and under Business Intelligence, find Integration Services. Notice the description on the right. It says, this project may be used for building high-performance data integration and workflow solutions, including extraction, transformation, loading, ETL, operations for data warehousing. This is exactly what we need. The tool is ready to go and we will learn how to use SSIS in one of the next sections in this course.
Data wrangling before the load. First off, data wrangling is just a fancy way of saying data preparation. And in this section you will learn what you need to do with your data before you upload it into a database. And throughout this part of the course you will notice that we are always assuming that your starting point is a raw CSV file. Well, why is that? That is because in most situations that will be the case, and even if it isn't, then from experience approximately 80% of the situations can be taken to that point where you are starting with a raw CSV file, and then you can apply this template. And so in this section you will learn the two things that you need to do with your data before you upload it, and also how to structure your folders in order to have a successful data science project. And let's jump straight into it.
In this tutorial, we will talk about folder structure for your data science project. And I will show you the tried and tested method that I use. Folder structure is important for many reasons. For instance, if you have a smart folder structure, then you will know exactly where things are located and your efficiency will go up. Also, a good folder structure will allow you to quickly audit any data errors that you might find. Let's assume that this is your folder for all data science projects. Let's open it up. Inside you will see that I have already created a template. Ignore the exclamation mark at the start, it's there simply so that the template is always at the top of the folder. You will notice that the name of the template folder starts with a date in a specific format and then the project name. The date is when you commence this project. Once the date is set, it cannot be changed. Note that it is important to state the date in this exact format because in that way your folders will automatically sort by chronological order when you sort them by name. Let's click into the template. Inside you will see the following 6 folders: original data, prepared data, uploaded data, analysis, insights, and final. Let's go through them one by one. The first folder is for storing data extracted from other systems. You can only add data to this folder and you should never, under no circumstances, modify any data stored in this folder. The second folder is for any modifications you may make to the raw data. This includes cleaning the data, which we will look at further in the course. Folder 3 is for uploading data. Think of it as the temporary stop for your data. Once you are ready to upload a file, inside this folder you create a subfolder with just the date of the upload for the name. And from within that folder you upload the data. We will see all of this in action in the next section. The analysis folder is for any code, scripts, etc. that you create during the course of your analysis. And the insights folder is for any preliminary results. Finally, the final folder stores your draft and final reports. This brings us to the end of today's tutorial. Feel free to copy this folder structure template as we will start using it already in the next tutorial. In this tutorial, I will show you where you can get the dataset for this section. As usual, you need to go to superdatascience.com/training, and now if you scroll down to part 3 data prep, then here in section 2, ETL phase 1 data wrangling before the load, you'll find a file which is called bank customers demo. It's a CSV file. So go ahead and download that. I've already downloaded it and it's on my desktop over here. And now what we're going to do once you've downloaded the file, we're going to create a project folder for our data science project. And we talked about project folders in the previous tutorial. We're going to be using them throughout this whole part of the course. So it's very easy to create a project folder once you have the template prepared. So this is our template which we talked about in the previous tutorial. What we need to do is just simply copy this template. So I'm just going to hold down Control and drag it down, makes a copy, and I'm going to give it a name. So 2015 08 03, and then I'm going to call it, of course we need to get rid of the exclamation mark, so we're going to say bank customers demo. And now once we get into the template in the original data, we're just going to take this file and we'll put it in there. So there it is, bank customers demo. And it's as simple as that. We'll pick it up from here in the next tutorial, and I look forward to seeing you then. Okay, so we have uploaded the file into our original data folder. Now we're going to perform some cleaning on it. We cannot change the file within the original data folder as we discussed, so what we're going to do is take this file and copy it and put a copy in the prepared data folder. Now we can work with this file and make any changes that we need. So let's open up this file in Excel. We're going to bring up a copy of Excel, and I'm just going to drag this file into Excel. Here you can see that it has several columns and not many rows. That is because this is a demo file, and we will work with our much larger file in the following sections of the course. So here you can see the different columns such as customer ID, name, surname, gender, age, date joined, and balance. Now there are two specific things that you need to do with this file before you commence the upload. You need to fix up the dates and you need to fix up the balances. So what do we mean by fix up the dates? Well, dates can have different formats, and we want to have a consistent format in all of our data in our database so that we know exactly how to work with it. Plus, sometimes you might get a date from a European country that structures its format differently to the US. So you have to account for those things and make sure the format is consistent so your database can recognize the date wherever the original data came from. And the second thing is fix up the balance. We need to get rid of the dollar signs, the commas, and make sure the decimal places are represented by dots. So let's go ahead and do that. All you need to do is select the column that you're trying to fix. So we just look at the format at this stage and right click on it and select format cells. Here for date, we're going to set a specific type of date. So under date, we're going to select, it's actually not here for me, so I'm going to have to go to special, no, custom, and I'm going to find date here, and I'm going to change it to, this is the type, the specific type of date that you need. So it's YYYY hyphen MM hyphen DD. That is the best date format for databases, because whether this data came from the US or whether you're working in the US or whether you're working in the UK or any other country, your database will know exactly that the month is if it sees the year as the first 4 digits, then it will see the month as a second and then the date. It will never confuse the month and the date. So we're going to click OK. So as you see, the date has changed its format, and now we're going to do a similar thing with the balance. We're going to format cells, and now we're going to go to, instead of currency, we're going to go to number, and here we're going to make sure this box is unchecked, the use thousands separated because we don't want the commas, decimal places 2, and we'll click OK. Now there we go. So now there's no dollar sign and there's no comma in the balance. So one more thing, if your country uses comma instead of a dot for decimal places, then you will have to change the regional settings of your computer to make sure this comma is changed to a dot, because when we upload to a database, you need a dot. So now this file is ready, and let's have a look at it again. I'm going to close this. It's going to save it. Yes, yes. And now what happens is if I drag the file back in here, you will notice that the balance stays consistent like we changed it, but the date changed again. It's not the format that we selected. And this might be confusing, but the only reason for that is that Excel displays the date convenient to you. So it looks at your regional settings and then it displays the date in that way, just for your convenience. So the proper way to check your data is not through Excel. So once you have modified it in Excel, what you need to be looking at is programs like Notepad++, so I'll just bring it up here. Here's Notepad++, and if we drag our data in there, now you can see that the date is in the correct format, as is the currency. If your data set is very large, there's a different program called EditPad Lite, and we will talk about that program later on in this section. So that's the two things that you have to make sure are prepared, the dates and the dollar amounts. Once you've prepared those, you're ready to proceed to uploading data to the database. Now we've already touched on Notepad++. However, in this tutorial, I just wanted to reiterate exactly why I use it and prefer it. Notepad++ is a very powerful editor for viewing text and CSV files. It is much more user-friendly than the standard Notepad that comes with Windows and has some major advantages over it. For instance, as you can see here, Notepad++ has row numbering, which means that you can seamlessly navigate through your files. Also, the search and replace feature in Node++ is very useful for data-related work. And when using Notepad++, you're confident that it will not inadvertently modify your data. And finally, perhaps the biggest advantage for data scientists is that while normal Notepad can only open up files up to 54 kilobytes, Notepad++ can open up files up to 2 gigabytes. I highly recommend installing Notepad++ and completely forgetting about normal Notepad. EditPad Lite is a paid program similar to Notepad++, but has some additional advantages. The descriptions both say that Notepad++ and EditPad Lite work well with files under 2 gigabytes. However, I find that Notepad++ sometimes struggles, but EditPad Lite always works really well and much faster with very large files. Also, EditPad Lite is definitely much faster than Excel when it comes to very big CSV files. So if you're struggling opening your data science file with Excel or even Notepad++, then you should consider giving EditPad Lite a go. Also, if you have a file well over 2 gigabytes that you need to investigate, there is always a more expensive version, EditPad Pro, with its advanced features. An extra bonus is that EditPad Lite is free for personal use. So if you are working on some of your personal projects at home, you can get it at no charge. If, however, you intend to use it for work, then you need to purchase a license. Personally, I like the user interface in Notepad++ much more, and is free. I recommend sticking with Notepad++, but keeping EditPad Lite in mind in case you ever need the additional power. In this section, you will learn how to use SSIS, which stands for SQL Server Integration Services, and is a valuable skill in its own right. You will learn how to set up a source, a destination, and you will run your first package in SSIS. Also, you will notice that throughout this whole part of the course, we talk about quality assurance, or QA, quite a lot. And that is because QA is a very, very important part of the work of a data scientist, especially in the ETL phase. Imagine if you get your ETL wrong, just one step somewhere in your ETL is messed up, then your whole analysis after that is worthless. It doesn't mean anything because the data is incorrect. And that's why we'll be focusing on QA quite a bit in this part of the course. And in this section, you will get your first introduction to QA. I look forward to seeing our first tutorial. Today we're going to start our first data upload project in SSIS. This is going to be a really fun tutorial and we will learn a lot. Let's get straight into it. First of all, let's launch the Visual Studio Shell. Now select New Project here on the left. Under Business Intelligence, find the Integration Services Project option. Give your project a name, and in terms of location, I usually use the default folder. You are welcome to use the project folder, however, you might find it challenging because if the folder path is too long, you will get an error like this. So we will stick with the default folder. Click OK. Get rid of this Getting Started window, and your project is ready to go. As you can see, there are lots of different controls which may seem overwhelming at first, however, we won't be using all of them. We will focus on two main things, the middle section, which is your main workspace, and the SSIS toolbox on the left. At the top of your main section, you will see 5 categories. Forget about the last 3. We will only be working with the first 2, control flow and data flow. Now let's go to the toolbox and find the data flow task. Drag it into your main working area, and you have created a data flow task. Congratulations. It's as simple as that. All of your work in SSIS will be drag and drop. Now if we double click on the data flow task, we are taken to the data flow window. In simple terms, you can think of this as the control flow being the process that kickstarts the data flow. So there's a certain hierarchy between the two. The data flow is where you will specify which files need to be uploaded and where they go. We will start setting up our sources and destinations in the next tutorial. In this tutorial, we will set up the foundations of our data flow task. First, let's rename this task. The convention I use is to put the date at the start so that I know when this upload was set up. Now let's go into the data flow task. Notice that the SSIS toolbox changes as we enter the data flow task. Let's have a look at that again. This is the toolbox when we are in the control flow, and this is the toolbox when we are in the data flow. Let's collapse all of the menus in the toolbox. Ignore favorites and common, and you will see that the remaining 3 are called sources, transforms, and destinations. This, in fact, represents our ETL process. Data is extracted from the sources, transformed with the transforms, and loaded into the destinations. We will be mostly working with sources and destinations, and I will explain why further down in the course. Let's set up our data flow task. Go to Sources, select the flat file source, and drag it into your working area. This will point to our CSV file with the data. Next, go to Destinations and find OLI-DB destination and also drag it into your workspace. This will point to a table in our database where we want to load the data into. You can rename the source and destination if you like, but you don't have to. The last step we need to perform now is to connect the two. You will notice that there are 2 arrows coming out of your flat file source. The blue arrow is where the data goes, and the red arrow is where any error messages will go. You need the blue arrow. Connect the blue arrow to your destination. Great! You have now prepared the data flow. In the next tutorials, I will show you how to set up the flat file source and the database connections. In this tutorial, we will set up our flat file source connection. The first step in this process is to take the file we're going to be uploading and place it into the Uploads folder. Let's do that. This is our project folder. We have already prepared the file in the previous section of the course. Currently, it is located in the Prepared Data folder. Let's go and copy it. Now we need to go to the Uploaded Data folder. Here we will create a subfolder with today's date as the name. Now paste your file into this folder. This is the file that we're going to be uploading to the database. Copy the folder path and go back to SSIS. Now double click the flat file source box. In the flat file connection manager, you need to click New. Click Browse and paste your path. You cannot see any files right now because by default the tool is looking for TXT files. Click the drop down at the bottom of the window and select CSV files. Select your file and click Open. Now that we have found the file, we will set up the flat file manager. First, give the connection manager a recognizable name. I prefer to simply copy the name of the file. Next, change the text qualifier from none to quotation marks. This ensures that data in your CSV file is recognized correctly. Also, it is important to make sure that the checkbox saying column names in the first data row is checked. This simply means that the first row of your file contains headers and the actual data starts from the second row. It is checked by default for us, however in earlier versions of Visual Studio this option was not selected by default. We don't need any of the other controls in this window. Now let's click Columns in the options on the left. Here you have a preview of your data. The beauty of using a CSV file is that it's very simple. We know for sure that the row delimiter will always be the carriage return line feed sequence, and the column delimiter will always be a comma. This means that we don't have to worry about these two menus and should leave them at default. Now preview your data. This is quick and easy. Scroll as far to the right as possible. You need to check for two things. Check number one. Make sure that the last column is the same one as in the file that you prepared, and that there are no extra empty columns to the right. If you find extra columns on the right that shouldn't be there, that means that your CSV file contained empty columns and you should revisit the previous step, preparing your CSV file before the load. If those columns are not required, they should be deleted. Check number two. Now scroll down as far as you possibly can, and while you're doing this, look at all of the cells in the last column and see if they have the correct type that you would expect based on the column's name. In this case, a number. This check allows you to make sure that none of the rows available in the preview got skewed because of a data anomaly. A lot of data scientists skip this step considering it too trivial. However, I still always do it. I have done hundreds of these uploads and still I perform this check. Finding an error this way will save you a lot of time down the track. If all is good, then move on to the advanced step in the menu on the left. This is a vital part of your upload. If you wanted to here, you could specify the data types for your columns. A lot of analysts do that right here. However, I will show you a much better method. The method I will show you is way more reliable and safer. I won't go into all the detail right now. You will see how the whole picture will fall into place as we progress through this part of the course. However, what we will be doing here now is uploading all of our columns as text. It doesn't matter if it's a name or a date or a number, everything will be uploaded into the database as text. And then in the database, we will sort it all out. If you click through the columns, you will see that all of them have already been recognized by SSIS as text. This is indicated by the data type string over here. That's a good start, but there is one little problem. SSIS wants to save space and therefore has only allocated 50 characters to every single data element. That is not much at all, and if we have a cell that contains 51 characters, then our upload will produce a truncation error. We need to increase this memory allocation, and I always set it to 1000 characters. This is the safest bet by far. You can still come across data that has more than 1000 characters, but that's rare. An example of that would be if your column contains freeform text such as customer complaints or comments. Hold down the Shift key and select all of your column headers. Double-click the current column width and replace it with 1000 and hit Enter. Now all of your data elements will have 1000 characters of storage space. Go to Preview and check your data one more time. Click OK. Click OK again. Now your flat file source and flat file connection manager are ready. By the way, it is important to understand the difference between the two. The connection to your file is called the connection manager. You can see it here at the bottom. If you double click on it, you will see the menu we spent most of our time in. Now the flat file source is what you see in your diagram. If you open it up, you will see that the flat file source uses the flat file connection manager. This is just how SSIS works. The flat file source and connection manager are separate, and this means that you can use your connection manager in many different sources without having to recreate it. This is applicable to other SSIS projects, and we won't be using that in our work, but it's good to know these things. Alright, our flat file source is ready, and you can see that the red error sign has disappeared. In the next tutorial, we will set up the destination. Now we will set up the database connection. First of all, let's open up SQL Server Management Studio. Connect to the server you'll be using for this training. Now locate the database you'll be using. As you recall, previously in this course we created a test database called DS Training. I will be using it for this tutorial. My database currently has one table. This is the test table that we created earlier. At this stage, what we will need is the server name. Write down your server name somewhere and we will use it just now. Now let's return to Visual Studio and set up the database connection. Double click the OliDB destination icon. Just like previously with the flat file source manager, we will need to create a new OliDB connection manager, which we can then use in this OliDB destination. So click New. Now we need to connect to the server and the database. Click New again and type in your server name. Click Refresh, and now from the drop-down, select your database. Make sure your authentication method is correct. Throughout this course we are using Windows Authentication, and that is probably the one you need too, unless your database administrator told you otherwise. Click OK, and click OK again. As you can see, it is much quicker to set up an OliDB connection manager than a flat file source manager. And the best part is that we can use this connection manager in our future OliDB destinations within this SSIS project, because we will be most likely using the same database to store our data. Now you can see the OliDB connection manager over here alongside the flat file source connection manager. So far we have connected to the server and to the database. The last step is to create a table where the data will be placed. There are two options here. You can either create a table manually from within SQL Server Management Studio, or you can do it from Visual Studio, getting SSIS to do most of the work for you. If you use the first method, then after creating a table in SQL Server Management Studio, you can select it here from the drop-down menu. However, I recommend the second approach, where we create the table through Visual Studio. It is more efficient and nicely fits into our ETL blueprint. To create the table, click New. SSIS is smart and has already prepared the code for you. The table that will be created will have the exact columns that you need. But how did SSIS know what columns you need and what size they should have? Well, SSIS knows this because of the blue arrow that connects your flat file source and the OliDB destination. The blue arrow is telling SSIS that this table in the database will be used to store the data coming from that flat file source. Therefore, SSIS knows how the table should be structured. This can be very handy and save you lots of time when you're dealing with large tables with hundreds of columns. Let's go back to our table creation menu. As you can see, everything is nearly ready. We just need to make a few small changes. First of all, let's change the name of our table. I will demonstrate a convention that I use. Start the table name with raw. This will tell you or whoever is viewing the database that this table contains raw data for your analysis. Then put an underscore to separate the core of the table's name. Here type in the table name, preferably without any spaces or hyphens. To separate words, simply capitalize them. For us, it's Bank Customer Demo. Now put another underscore and enter today's date in the format which you should be getting used to by now, year, month, day. Let me pause here for a second and explain why appending the date to your raw tables is so important. There are a couple of reasons. One is versioning. If your analysis ever needs to be refreshed with new data, then it will be very easy to distinguish between old and new datasets because the table names have dates. Another major reason is auditing. Through this date, you will always know in which subfolder of the uploaded data folder the matching CSV file is sitting. This is important because it allows you to trace any errors back to the source. Back to the table creation. We are nearly finished here. Just one more thing we need to add. It's an extra column. Follow me and after I will explain what this means. In square brackets, type in row number as one word. This is going to be the column name. And after that, type in the following row of text. Int identity, left bracket 1, comma 1, right bracket, and finish off the row with a comma. The code that you have just added will insert a row number column at the start of your table. Make sure to do this for every table you create via SSIS. This helps with indexation, especially with large datasets. Basically, what this means is that they become more efficient and they take up less space. Your database administrator will thank you for it. By the way, we won't be covering schemas in this course. However, if you are restricted to working with a certain schema in your database, then you should add your schema name before the table name like this. Simply put it in square brackets followed by a dot. But I'll delete this now because we won't be needing it. Now we're going to click OK. However, before we do that, note that as soon as you click OK, SSIS will create your table for you. Alright, now let's go have a look at our table. Right click on the tables folder and hit refresh. Here you can see the new table. Right click it and choose select top 1000 rows to get a preview of what is inside. The table is empty, but it has the right columns prepared, including the row number column which we just added. Let's go back to SSIS and finalize the OLEDB destination. Here you can see that the newly created table has been selected for us in the dropdown. Don't worry about the rest of the options on the screen, we won't be needing them. At the bottom you see a warning message, it is asking us to map the columns. Let's go ahead and do that by clicking on the mappings page. If you follow the steps carefully, then you won't have to do anything on this page, the columns are already mapped for you. Now you can click OK. Your OLEDB destination is ready. On my screen you can see that the red error sign is still there. If I hover over it, you will see more details. It says the column customer ID cannot be processed because more than one code page, 1252 and 1251, are specified. You should not have this error on your machine. All it is saying is that SSIS is confused as to which code page should be used to upload text data to the database. This is simply because I have installed multiple languages on my machine, English and Russian. If you do encounter this error, all you have to do is select the OLEDB destination and in the properties window on the right, set always use default code page to true. As soon as I do that, the error changes into a warning and it really shouldn't bother us because we know what it's all about. And that brings us to the end of today's tutorial. Hope you're doing well so far and learning lots of new stuff. Next time we will run the upload process. Finally, we have prepared everything and today we will run our first data upload via SSIS. I hope you're as excited as I am. Without any further ado, let's get straight to it. To run the upload, simply click this green start button up at the top. That was quick, wasn't it? That is because this is a training file and only has 20 rows. Further in this course, we'll be working with much larger files. The package has been executed successfully, and to return to design mode, we can either click the stop debugging button at the top or click on the success message at the bottom. By the way, if errors occur during the upload, this message at the bottom will tell you about it. But we'll deal with that in the next section of the course. Let's return to the design mode. Now let's have a look at our table in the database and check if the rows are really there. Right click and choose the select top 1000 rows options. We can see that all 20 rows are present. Perfect. We have one more thing left to do in SSIS. Let's go back to the control flow. The idea is that for every analytics project you're working on, you will create a new SSIS project. Within every SSIS project, for every new data file you upload, you will create a new data flow task just like this one. This means that the number of data flow tasks in your control flow will be equal to the number of files that you upload to your database. The reason this is important is because when you click the start button, you are launching the control flow and not an individual data flow. It doesn't matter if you're browsing inside a specific data flow you want to launch, you will still always launch the control flow when you click the green button. That means if you have 5 data flow tasks within your control flow, then all 5 of them will be executed. We have already executed this data flow once and we don't want it to run again, ever. If that happens, then the data in the table will be duplicated. A lot of starting out data scientists and analysts make this mistake, and I have made it before too, and that's why I want to caution you against it. To avoid duplicating the data, we need to disable this data flow. To do that, simply right-click the data flow and select Disable. And now save your project. That's it, the upload has been completed and the data flow task has been disabled. By the way, we're not deleting the data flow task simply because we want to keep it for future reference. That's all for today. I hope you enjoyed the tutorial and next time we will talk about quality assurance of this phase of your ETL. Quality assurance, or QA, is an important aspect of the work of a data scientist, and we will be talking quite a bit about it throughout this course. QA is especially important in the ETL phase. Imagine that an error occurs in your ETL and you don't pick it up. The rest of your work that you do after the ETL is pointless because the underlying data is flawed. Today I'll show you some quick checks that you can do after you have uploaded your raw data. The first thing you should do is check the number of rows. Here's a handy trick on how to do it quickly. After you have selected the top 1000 rows of your table, highlight everything between select and from. Now delete this code. Replace it with simply count, left bracket, star, right bracket. Now click this red execute button up at the top. As you can see, SQL displays the number of rows in your table in the results window over here. There are 20 rows in this table. And this is correct because we have 20 rows in the original data file. It is important to compare it to the original data file and not the prepared or uploaded data. You want to make sure that the number of rows has not changed anywhere throughout your ETL. Of course, if you had deliberately deleted some rows in the preparation stage, then the situation is different. In that case, you need to compare this number to the number of rows in the file in the prepared data folder. Another thing you can do is scroll through your data and make sure that no rows have been skewed. This process is similar to the check we did in SSIS. Simply look at the most right column and scroll down throughout your file. Also, you should check that the dates have been uploaded correctly in the year, month, day format. The same goes for any dollar values. Make sure that there are no dollar signs or commas and that there are only 2 digits after the decimal. These are very trivial checks, but they can help you catch errors that could have occurred during this phase of the ETL and save you lots of time down the track. So far, this part of the course has been cakewalk, don't you think? Everything has been fluffy, smooth, and nice, but I did promise you some real-world data. And today, you will get real-world data. The data in this section is dirty, messy, it's corrupt. You will see errors like truncation errors, text qualifier errors. You'll even see how Excel will mess up your data. In short, it'll be a whole nightmare. But at the same time, you will learn a lot. You will learn how to deal with those errors. We will talk about some advanced SSIS techniques that will allow you to automate parts of your error handling process. And the best part is, at the end of this section, you will get homework, which you will have to do all on your own. So definitely listen up carefully. These things that you will learn in this section are very important. Alright, let's go ahead and download the dataset for this section. As usual, you need to go to superdatascience.com/training. Then if you scroll down, Part 3 Data Prep, we're looking at handling errors during ETL phases 1 and 2. And here the dataset is fakenames.zip. So if you go ahead and download that, and then you will get a zip file and you need to copy that into your project folder. So I've created a project folder for this project. I've called it fake names. And inside here in the original data, you copy the zip file and also the CSV, which is inside the zip file. And once you've done that, proceed to the next tutorial where we will pick up this process. Today I will show you the dangers of dealing with Excel. As always, let's copy the file from the original data folder into the prepared data folder. The safest way to explore your file is to open it with Notepad++. Let's do that. First off, this is not a good way to display CSV files. We want one row of data per line. If your file is being displayed like this, then you need to toggle word wrapping. Go to View and uncheck word wrap. Much better, isn't it? You can see that there is lots of data in this file. In fact, over 50,000 rows. You can already see some data issues over here at the bottom, but we'll deal with them later. Right now, I would like to show you something else. Scroll up to the top and scroll about halfway to the right. Pay attention to two things. Do you see that all the dates have slashes and are in American format? From this record in row 3, you can tell that the month comes first, then the day, and then the year. Let's look at the first row again. Here you can see that the date is 11th August 1991. Let's remember that, 11th of August. The second thing I'd like you to notice is that the dataset has credit card numbers. By the way, I want to reiterate that these are fake numbers. But what you can see is that all 16 digits are displayed in this data. Now let's close the file. Open up Excel and drag your CSV into Excel. Now, without doing anything, simply save your file and open it up again in Notepad++. Scroll to the right and look at your dates now. You can notice the dates in row 1 and 2 are presented with dots instead of slashes. But the funny thing is that the date in row 3 is still presented with slashes. Note that this might not be the same for you because this effect depends on your computer settings. If that is the case, then just follow along what's happening on my screen. So what happened here? Excel saw data which it recognized as a date, and it decided to convert it to a format that is convenient for me to read. How does Excel know which format I prefer? Well, it simply looked at my computer's regional settings and saw that I am used to the day, month, year format with dots and not slashes. So what it did is went and changed the data for me, but it did it incorrectly. As you can see, the date in the first row changed from 11th August to 8th of November. Excel thought the dates were in European format and mistook the month for the day and the day for the month. This observation is backed by the fact that the third row has remained unchanged. The reason is that Excel did not recognize this record as a date. It was looking for a day, month, year, and since there is no month with number 27, Excel decided that this is not a date and left the record as is. In short, Excel completely messed up your dates. Now let's look at the credit card numbers. Where are they? They aren't here anymore. Excel has replaced them with a scientific number format. As you can see, we haven't even started the ETL process yet and have already caused ourselves additional problems. Plus, while the date issue causes major headache, it is still reversible. On the other hand, the credit card screw-up is not. You cannot retrieve the full 16 digits from this format. Imagine the consequences for an organization which loses its customers' credit card numbers, especially if this is the only copy of the file. This illustrates the importance of never touching your original data files. Even just opening them in Excel can mess them up. Now let's close this file and delete it. It's useless to us because the data has been jeopardized. Next time I will show you a bulletproof method for data wrangling. Last time I went on a rant about Excel and now you're probably thinking it's a horrible tool that will ruin your career. The truth is I don't have anything against Excel. You just have to know how to use it correctly for data science work and everything will flow smoothly. And that's what I will teach you in this tutorial. To start off, let's copy the file from the original data folder into the prepared folder. You can now see how valuable it is to always have a copy of your original file in the case of a screw-up. The next thing we need to do is to change the file extension from CSV to TXT like this. Note that if you cannot see your file extension, you can easily fix this. Simply click anywhere in your folder, then press Alt on your keyboard. Now go into Tools, Folder Options. Go into the View tab and uncheck the box that says Hide Extensions for Known File Types. Click OK. Now you should see the extension. Next, open up Excel. Instead of dragging the file into Excel, we will open it up within the program. And because this is now a TXT file, this will force Excel to bring up the data import wizard. Go to File, Open. Now copy your folder path and paste it into the open window. Select all files in the bottom right and choose your file. And now click Open. You can see that the import wizard has popped up. In the first step, make sure Delimited is selected and click Next. By default, the tab delimiter is selected. Unselect it and change it to comma. Also make sure that the text qualifier is set to quotation marks. You can see that the data preview has changed and your columns are being recognized correctly. Scroll through to the right to make sure all your columns have been picked up correctly. Now you can click Next. Step 3 is the most important step. We're going to tell Excel not to guess our data types and instead import all of it as text. This is how you do it. Select the first column and then scroll to the very last column and select it while holding down the Shift key on your keyboard. This selects all of your columns. Now in the column data format, select text. And now click finish. After a second or two, the data will load and now all of it is recognized as text. Essentially, this is the same thing as what Notepad++ does, but it's just easier to navigate. As you recall, there are two things that we have to do in this phase of the ETL. Fix up the dates and fix up the dollar amounts. Today we will add a third item to that list. First, let's fix up the dates. Since all of our data is in text, the previous method won't work anymore. Simply changing the format of a column won't do anything. Follow me and I will show you a technique that works for text fields every time. Select the whole column. Now go to the Data tab at the top and find Text to Columns. A familiar wizard pops up. This is the same wizard we used to import the text file, only now we're using it for one specific column. Make sure Delimited is selected and click Next. Now uncheck any type of delimiter. We're dealing with only one column and therefore we don't need a delimiter. The text qualifier doesn't matter either. Click Next. Your column is selected at the bottom. All you have to do is change the column data format from general to date and specify which date format Excel will be dealing with. In our case, it's month, day, year. Finally, the destination here is X1, which means that the new data will replace your old column. That is exactly what we need. Click Finish. As you can see, the dates have now been recognized by Excel correctly. Now we will change the format of the dates just as we did previously. Select the whole column, right-click and choose Format Cells. If your Excel has the format we need under the Dates category, then select it there. Otherwise, go to Custom and specify the format we need. Since we've used it before, Excel has saved it for us. Select it and click OK. Now, dates are in the right format. Remember, you need to do this procedure for every column that has dates in it. By the way, you've probably noticed that this process is taking quite a while and we haven't even gotten to the SSIS stage yet. This is exactly what I meant when I said that ETL is about 70% of the work of a data scientist. This is the reality of things, and that's why it's important to have a bulletproof ETL framework. It not only saves you from errors, but will also save you lots of time. Okay, let's get back to it. Now we are going to fix up the dollar amount. Similar approach. First, we need to convert the text into a number. Select the whole column and click Text to Columns. Same thing, delimited and no delimiter. In the last step, for column data format, select General and click Finish. Now we can format the columns. Highlight the whole column and click Format Cells. Choose a number, 2 decimal places, no thousands separator, and for negative numbers, select the option with a minus. Click OK. Perfect, we've done the two things, dates and balances. Now let's add the third item to our list. Viewing CSV files in Excel through the TXT method is safe and convenient, but it comes with a price. Have a look at this feedback column over here. You've probably already noticed these hashtags in some of the rows. If you click on the cell, then in the formula bar you will see that it does have text. However, it's replaced with hashtags in the display. This happens when the text is too long. Excel can only fit up to 256 characters into each cell, which is formatted as text. If you save the file now, you will lose this data. In order to fix the problem, select the feedback column, right-click, and select Format Cells. Select the general category and click OK. Now the comments are being displayed correctly. Great, your file is ready to go. Let's save it. Click File, Save As, and from the drop-down, select CSV. Click Save. Close Excel, and now you can delete the TXT file. Let's have a look at the CSV file in Notepad++. Here you can see that there are no hashtags. The balances are being displayed without commas or dollar signs. And if we scroll over to the right, you can see that the dates are shown in the right format. The first row has been correctly recognized as 11th of August. And the credit card numbers are still here. That's perfect. The file can be uploaded now.